All right, so welcome everyone. We have more people registered, so maybe we will have some additional attendees joining later on. Welcome to this training session about Libnova's development in the context of the ARCHIVER project. I believe most of you, if not all, are familiar with the project, so I'm not going to spend any time explaining this and just focusing on the different topics that we are going to cover. This is a long session covering morning, then we have a lunch break, and then just finishing off in the early afternoon. We think in this manner you will have a more comprehensive understanding of LabDrive, which is the product that we name for the result of the ARCHIVER project, the things that we have been analyzing, designing, developing, and everybody testing in the group. So the session today is going to provide you with an introduction. Then you have introduction covering architecture and how research content, because LabDrive is mainly focused about research data management, as you can see in the screen. Then you'll have a full explanation about different aspects of configuration, and then we'll move to the actual operation of the platform. The session is being recorded. I think I mentioned that at the beginning, sorry. It's being recorded, so either you or your colleagues afterwards will have the opportunity to review content and all that. We are going to provide also a link in the chat for registration and participation in this meeting, and also a feedback form, so you can give us your feedback in the different aspects, so we can understand better what are your intentions, how you feel that the content in the session has fulfilled the objectives, whether you miss some things, so we can prepare something better for the future. So with this introduction, my colleague Maria is just pointing out to the actual register and the feedback forms. So with this, I will just transfer full voice and look to my colleague Antonio. Antonio, the floor is yours.
Thank you, Theo. And thank you everyone that is here today. Good morning. So thank you for your interest in this training session and for your interest in our products. So as Theo said, we are going to be focusing in the first section on giving you an introduction, what is LabDrive, what has been designed for. Then we will look at how you can adapt it to your needs. So one of the most relevant capabilities of this product is that it's very flexible to adapt to different workflows and different needs. So we're going to see what tools do you have and you can use. And then we're going to start looking at the day-to-day operation. So we're going to start using the platform and showing you what kind of things could be done, how the API is used, and so on. And at the end, we will have a Q&A section. You have the questions and answers interface in the Zoom meeting, so you can also use it to start sending me questions. Depending on if those questions are going to be answered later on in the presentation, I will skip them, and if not, I will answer them immediately. But please feel free to send them as you have them, and I will try to answer them in the most convenient way. Okay, so about our company. So just a quick presentation. We are a market leader in the digital preservation and digital content archiving field. And basically, our customers or organizations are using our solutions to safeguard and provide access for their valuable digital assets in the long term. We offer cloud and on-prem based services, and we have customers in 17 countries, some of the largest organizations worldwide, and also some of the smallest, of course. But here we have the most representative ones are using our preservation platform. So many national libraries, world-leading companies, universities, and organizations. The company is almost 14 years old. We have a very recent and modern product architecture, and our platforms have been massively adopted in the last few years. We are the only major self-sustained company. We don't have venture capital, we don't have risk capital, we don't have debt. We can look, we have the full control of the company, and we are keeping always doing what is better for our customers. And our approach to working together with them is basically a long-term partnership approach. Unlike other products or other systems, digital preservation and content archiving is going to basically keep us working together for, who knows, 10, 15 years in the future. So everything in how we work and how we manage those relationships is looking at the long term and the partnership approach. So, but what about LabDrive? So LabDrive is a research, data management, and preservation platform. As you can see, we are highlighting here the data management, research data management part, and not only preservation. We're following 3 design principles for this platform. The first one is that this platform is unified, allows organizations to combine everything they have in a single unified and rationalized platform. So we are trying to basically remove the different silos or different platforms that are usually not managed in full or not cost effective, to propose something that to provide something that could be used for the whole content organizations have. The second design principle is that this is a really comprehensive platform. We're going to see it today. So it is not only allowing organizations to properly archive and preserve their content, but it is allowing them to capture in it as soon as they generate this information, and allows organizations to work together and users to basically collaborate when building those data sets. And this is a solution that is offering help not only at the end of the life cycle, at the end of the archiver state. It has been designed to offer support for the whole life cycle. We will see that. And the third principle is that it is open. It's an open platform. So we're keeping full transparency about the procedures and about how the platform is managed. The platform is being certified using the ISO 16363. This is the gold standard in digital preservation. But it is also certified in the ISO 27001 information security, 27017 and 18. Both are basically for increased security in cloud environments, and this is for GDPR and PII management compliant. 100% of the information you have in the platform can be easily exported. So there is nothing that can be extracted easily from the platform. There are no exit barriers at all. So we understand that today you are using this product, but tomorrow you may be using another one. So this is not only possible, but also easy. And we have created the platform in a way organizations can extend it and customize it by themselves to their needs. So we may be involved on helping you to adapt it to your needs, but you can also do it on your own. So we designed it for you to be able to extend the platform in many different ways without needing us. So if we focus on the unified, so as I said, this has been designed to basically allow organizations to transition from today's scenario in which every project, every data set, every department has its own tools for keeping the information and for managing it. The approach in LabDrive is to transition to a unified repository. And this, of course, takes into consideration the different nature of those different experiments, data sets, projects, departments. Some are going to manage some kind of data sets, really large, that are rarely accessed, while others are going to manage small things without metadata that are being built by the team. And the platform is capable of keeping both types of content managed under the same platform. This is taking into consideration and improving the risk management. Everything is managed in a single platform. So you have a unified understanding and a global view of what you have in the platform. It is capable of also of managing publishing and rights management. So how this information is used, how it is pushed to other components and so on. You have also a unified permissions management. We have also integrated it with SAML and other single sign-on platforms. So you can also integrate it with your directory and basically assign permissions on what are the user groups that are capable to perform which actions over which data sets. We're going to see that also today. And it enables you to apply policies in a unified way. So you can, for instance, decide that this department or this experiment or this project is going to have this particular policy on using those file formats, those metadata schemas, data structures, enforce them or leave users to choose, right? So you can define that per container in the platform. It allows organizations also to have unified infrastructure management. The platform is taking care of managing the underlying infrastructure, including, for instance, the storage. So you can just using an API call or just with a click in the interface, you can tell the platform to move something to a highly performant storage, or to move it to something like Amazon Deep Archive storage, in which the cost is really low, right? So, and this is fully managed. The transition from one to the other, keeping the integrity and all the metadata properties and so on, is managed by the platform. You can also define policies. So I would like, for when I ingest content after 30 days, to move this content to a cold storage, and the platform is taking care of this by you. And at the end, everything results in a cost control. So you can understand how much this costs, and you can also understand it to the project, department, team level. So you can understand how this is impacting the overall cost of the solution in a very granular way. The second principle is that this is a comprehensive platform, comprehensive in many ways. The first one is, as I told you at the beginning, this is not just an archiving platform. This allows you to allows your teams to work together, building those data sets and resources, use it, enrich them, analyze them in a single platform. Of course, you could use that, use LabDrive as an archiving platform, and that's it. But if you start earlier and start collecting the data in the platform, the preservation later is going to be, and the data management is going to be much easier, and it's going to have, it's going to be much better done, and it's going to have a way lower overall cost. So as you can see, if we look at the traditional approach to research data management, we are offering support on collecting data. For instance, the LabDrive platform is able to create metadata in an automated way. It is capable of extracting metadata from more than 3,000 different formats. So if you upload an image, the system is going to extract all embedded information and is going to move it to an internal database that can be used for searching or for creating different views of different objects. It is also allowing users to create their own metadata schemas to describe those data sets in a very flexible way. Those data sets could be a simple file or could be petabytes of data in millions of files, and the system allows you to basically create all those structures. So the concept here is a shared folder concept. It's not a monolithic platform in which you put something and you archive it and you forget about it. It's some kind of shared folder in which everyone can work together, can, of course, if they have permissions, modify things and so on. The platform is taking care of the complexity of all these things. So, for instance, if you create a new file, the system is keeping the previous version of the file. If you change the metadata, the system is creating an event in which this user is changing this value from A to B and so on. So the platform is retaining everything that will be needed for later, for managing this information and for properly preserving it. In the processing and analyzing, we have several very innovative concepts here. The first one is, for instance, you have Jupyter notebooks included in the platform. So you can have your data sets, and alongside with them, you can have your Jupyter notebook file. Your users could log into LabDrive, double click in the Jupyter notebook file, and then the Jupyter notebook is going to open, and this Jupyter notebook is going to be using the data that you have in the data sets that are also managed by the platform. This is not only convenient, but also very good for preservation, the preservation side of things, because we in traditional or in all the school preservation fields, the code that analyzes the data and the description of the data is sometimes forgot and not included in the overall process. This approach allows organizations to keep everything together in the same platform from the early days. The second relevant thing about preservation and processing is that we have a Lambda engine for the ones that are not familiar with the concept. You can think about it like a macro for an Excel file. So you can you have your content and your data, and you can add your own code to the platform, and this code will be executed by demand. So when you launch the process, or could be executed by the platform as a trigger process. So every time you create a new file, every time you edit the metadata, you can write code that the platform is going to execute. So let's say you have a data set in the platform that you would like to apply standardization in the naming. You would like to rename everything to, I don't know, include the date as part of the file name or whatever. In the traditional old school preservation, you need to do that outside of the platform. In LabDrive, you can create your Python code as a macro and you can execute it. This has many benefits. The platform is going to keep track of the changes, is going to keep all this provenance information together, and is going to be much faster and cost effective because the process is executing close to where the data is. And the third part about this is that we are including and we are embedding in the platform many powerful analytics and tools like Jupyter Notebook. We are including reproducibility engines and so on. But sometimes you need to use your own analytics platform. And here is another way in which the platform is unique. Everything you have preserved, every data set you have in the platform is stored in an underlying storage that, if you are using the cloud version, is Amazon's S3. Your files are structured in the same way as the structure you have in the platform, and you can directly access them using S3. So you will see that S3 is one of the most used object-based ways to access files. So you have hundreds of different tools that are able to talk with and using S3 protocol. Every tool that have S3 compatibility, you can use it to analyze the data you have. On top of it, there are many already functionalities and analytics and available, for instance, from Amazon. You can get them, and you can. They are going to be able to play with all the data sets you have managed in LabDrive. The platform is also helping organizations in the publishing and sharing of content. So the platform is capable of managing the the rights on publication workflows, for instance. And we are particularly proud of one of the customers that is using this platform is connecting it with Invenio, for instance. This is something that you would usually need to wait for the producer of the software, so for Libnova to implement. But in this case, due to the capabilities and the extensibility of the platform, the customer is doing it on themselves. So they have a fully functional integration right now, and they are improving it on managing their own custom workflows and so on, right? So we have an agreement to basically bring all this functionality to LabDrive so other customers can benefit. So we have several really interesting things happening there. Of course, in the preservation side of things, we are a world leader on digital preservation. So you could expect, you would find in the platform everything you could expect related to preservation. The platform is fully aligned to the OIs. It is ISO 16363 certified. We are in the final process of certification. This is going to be the only commercial platform that has been for managing research data that has been able to certify in the ISO 16363 standard. So it's fully aligned with OIs, and this is externally verified. And you have everything that is needed related to preservation, so characterization, file validation, fixity checking, storage management, and everything related to metadata, even for complex data structures and so on, is there. But in addition to that, in the last stage of this, the platform is also offering a lot of assistance. So there is a powerful search engine. So but just by ingesting something in the platform, which is as simple as drag and dropping it to the platform, the system is going to extract any technical information it is capable of. So we are, as I said, we are offering support for 3,000 formats right now, but you can extend it. So you may be using a custom format. You can write the code for the platform to be able to automatically extract properties from those files. This is already built in the platform. And all this information is indexed and instantly searchable. This is not only for your metadata, but also for embedded metadata, and also for the full text content that is in the file. So if you upload an XML file, a CSV file, this is indexed and searchable. You can perform, for instance, full text searches over the content. The search engine allows organizations not only to basically perform those metadata-based global queries, but also create custom groups of content, filtering them by metadata. So for instance, you could make a request, we will see in the training session, in which you are going to ask the platform, give me any data set related to this project that has been created between 2020 and 2021 that contains the word temperature and is larger than 300 gigabytes. You can create this query and the system will provide back every object that is matching your query. And this is done almost instantly. So even if you are querying millions of files, we have been testing this during the ARCHIVER project, your results are usually coming in less than 1 second. So never, the platform has been never taking more than 2 seconds to perform those queries, even if you are retrieving thousands of elements. You are querying for thousands of elements. So we have been working really hard to optimize this and to convert it to create a really powerful search engine that you can use to get your content back. But in addition, we have embedded in LabDrive a reproducibility engine. We will see it during the training, but for instance, if you have a Thurns Rihanna workflow there, if you have your YAML file and your C++ code in the platform with your data set, you can double click your Rihanna YAML file and the platform is going to start the workflow, is going to compile your C code, is going to execute it, and is going to upload the results to the container UR. So it's something that usually takes substantial amounts of time to integrate and put together. There is already built in. This is impacting many areas. So for instance, it is not only being able to run those workloads, but the cost of running those workflows is managed by the platform. So you know how expensive this is. The access control, who is able to perform those, to run those workflows, to which data sets and so on. This is also managed by the platform. As we are extending the Rihanna workflow, you can also run SnakeMake or other reproducibility workflows. And in addition to that, you have Jupyter notebooks that could also be used for analyzing the data and managing the content you have in the platform. It's not only, LabDrive is not only a comprehensive solution because of the data management, but also because of we have a unique approach to the package and to the content generation. All school solutions basically need for everything to be packaged together, and then you ingest it in the platform, and then no one is expecting for this to change. This is completely changed in LabDrive. You can, of course, do that if you wish, but the platform allows you to also ingest the information as soon as you have it ready and enrich it later. So when adding your metadata, you don't need to add it to the package and then ingest it to the platform. You can ingest what you have and then enrich it later. You don't need to package your data sets together in order for them to be ingested. You can upload them to the platform as you have them and then reorganize, restructure them. And you can see how convenient this is, because during the life cycle, if you are going to work together with your team in this kind of platform, this is going to be extremely helpful, because you can start working in the data set, start shaping it, refining it, cleaning it, and so on. And every step of the process is captured by the platform, and the package is there and under full control of the administrators and project managers. The platform is also really comprehensive. We think that it is because it is capable of adapting to different organization needs. There are organizations that are using a lot of metadata, very deep, nested and complex metadata structures. The platform supports them. There are other organizations that are almost using no metadata, and they are keeping their descriptive metadata in external platforms and only linking objects. LabDrive supports both scenarios. There are organizations that are using standard metadata schemas, which is always recommended for digital preservation, but there are others that are using their own metadata schemas or are using standard metadata schemas with 3 extra fields they're using for whatever. The platform allows you to also fulfill this need and have custom-made metadata schemas or use standard ones. There are organizations that prefer to use premise vocabularies for the preservation metadata or METS structures. They can use them. There are organizations that prefer to not to use them. This can be also done in LabDrive. Regarding the workflows, we see that there are organizations that have a clear processing workflow defined for their content. So they create it this way, then they process it this way, they extract this information, and they do whatever thing, and then the platform needs to publish it to other publishing and Invenio, a kind of platform or whatever. The workflow is clear. LabDrive allows you to create those workflows per project, per department, per organization, or allows you to work without the workflow, allows you to implement it later, right? It's rather flexible also to this respect. Regarding to the permissions, not everything needs to be available to everyone. Not everything can be changed or modified by everyone. The platform includes needed functionality for organizations to be able to properly manage this. In relation to permissions, as I told you a few minutes ago, the platform has been integrated with SAML, and this integration is not a basic one. It's a very deep one. So, for instance, the platform is capable of creating accounts based on the attributes for the users that are trying to log in. So this means that you don't need to even create those accounts in the platform. You can tell whoever is coming that belongs to the experiment X group, create an account and assign those permissions in the platform to access these data sets. And this can be also automated. The platform includes the enough metadata structures for organizations to be able to define and track rights. So, for instance, you don't have the metadata in the platform is not only at the string field or whatever. You have proper control vocabularies and lists of elements you can use for defining those rights that could be also used by other platforms that may be connected to this and so on. And storage and of course a cost of operation. So if we look at the storage, as I said, the platform is able to use several tier levels of storage. Not everything needs to be in the most performant type of storage or in the least in the slowest deep archive thing. You can have your containers, your files, individual files could be stored in cold storage, while others are going to be stored in hot, immediately accessible storage. So I told this could be this could be automated. So you can tell the platform, you can provide policies for the platform to manage the transition from one storage type to the other. And you can manage the cost you can understand the cost to the container level, to the data set, to the experiment, to the department level. It's up to you on how you organize your data structure. We will see how we recommend for you to do so during today's session. One thing that is interesting also that I would add about the cost is that we have created a pricing model in the platform that is able to adapt to really small research organizations with only a few hundred data sets or gigabytes of content. But it is able also to adapt to larger organizations with multiple petabytes of data. So the platform is also organized to the pricing model is organized really well to adapt to different customer needs. And to basically related to the to how comprehensive the platform is, and related to what I just said, this platform has been demonstrated to ingest 15 petabytes of data. We did it in 31 days. So the ingestion rate was 500 terabytes a day. And we were not using the full capabilities of the platform. So this can be faster if needed for a particular organization. So at the same way, this will work from a few million files, a few gigabytes of content. This will also scale to multiple, has been demonstrated to scale to multiple petabyte workloads. One benefit of using the underlying S3 storage is that we can parallelize access to the file system, which is usually the bottleneck of these kind of systems. The core platform, we will see it in the architecture, is also running in an auto-scaling Kubernetes engine. So when no one is using the platform, we may have a few hundred pods running in the platform. And when someone is ingesting a few million files, the system will scale up to 5, 6, 7,000 pods that are working in parallel to be able to achieve this level of performance during any of the different processes. And to finish with the overview of the why we think that this is a comprehensive solution, we have been working really hard to make this platform in a way it protects the environment. So we have been working in policing every single detail we have been aware of to try to generate a minimal emissions and to create the minimal possible workload on every possible element. We have been, instead of using already built libraries, for instance, we have been building our own hashing algorithms that in a single pass, reading the file a single time, are able to create up to 17 different hashes for the same file. This, in an old school platform, if you would like to have an MD5 and add the Adler 32 and a SE1 hash, you will need to read the file 3 times. In our platform, it's only processed 1. This is not only fast, but also is protecting the environment and taking care of this. The platform is not keeping all those resources in use, even with no one is accessing it. It's auto-scaling it to be able to accommodate to different workloads and to basically create the minimal possible emissions. To enforce that, we have been building a real-time emissions gathering engine in the platform. Every component that is running, and we are not using the cloud provider metrics. We are creating our own metrics. Every process, every single byte that is computed by the platform, this process, that it's transferred, we are getting this information to a data structure that we are later processing in order for customers using it to have a dashboard they can use to understand the environment impact they are having. We will see it part of this training session. And to finish, LabDrive is open. We think that this is open because it is aligned with the most possible open and widespread standards in the industry. So it is externally certified with the ISO 16363. As you know, the ISO 16363 is the gold standard in digital preservation. It's way more advanced than any other certification schema, Core Seal, and so on. We are choosing the highest possible, the most comprehensive standard to evaluate this platform against. So we're getting the certification in July. the certification process has been part of the ARCHIVER project. So we truly understand part of our consortia, the team that work to basically build this platform. We have been we have David Jarretta on board that, as you know, was the most relevant individual that participated in the creation of this standard. He's president of several committees related to preservation and so on. He has been telling us what the platform would need to do to be fully aligned and fully compliant to those preservation related standards and models. The platform is also fully aligned with the trust and the fair principles. We will see that later. We have not only, this is not something we are telling, this is something we are demonstrating. We have enough documentation, publicly available documentation to support this. The platform is also certified and externally audited within some of the most demanding security and compliance standard. For now, we have been certified in the 27001, and in the scope of the ARCHIVER project, we also achieved the 27017 and 18. So this is for GDPR enhanced PII management, and this is for enhanced security environments when running cloud workloads. We are the first major provider in the industry to be able to achieve this level of certification. And to finish with the openness of the platform, something that it has been really clear for us since our early days is that you need to be able to get everything you have in the platform whenever you want, without asking for permission, in the most easiest possible way. If you would like to leave, if you would like to stop using LabDrive and use another preservation platform, this is not only something you could do, but could be done in a very easy way, extracting 100% of the information. We have public information that describes how everything has been organized in the platform. You can extract everything. There is not a single bit of information in the platform you can extract. Other platforms allow you to retrieve the files and descriptive metadata. But what about the logs? What about the permissions schemas? What about your logic? The logic you are running, the code you are running in the platform to perform your workloads and so on. In LabDrive, you can export all those things. There is not a single element that can be extracted. And this extraction is documented. We have been adding Java code, Python code with examples that allow you to understand how this can be performed. And which is more important, it is going to be executed at full platform capacity, speed. So in other platforms, this has happened in our industry. Yeah, you can export your data. This is going to be a 1 megabyte per minute or 1 megabyte per hour or whatever. So it's really slow processes. Here in LabDrive, everything works really fast for if you need to extract a larger scale data set for you to be able to do so in a convenient and easy way. So I would highlight from here something that for us is relevant. If you can't extract your data from a system, it is not a preservation platform. This is, I would say, this would be acceptable by anyone. The thing today now is how easy is this done? So is this something that is involved months or weeks of work, or is this something that is already there and documented to be able to be done? In our case, it is the second. Okay, so to recap, as you can see, the really strong principles we are embedding in the platform is that it's a unified platform. We are trying to allow organizations to unify all their experiments, data sets, departments, and so on in a single unified and rationalized platform. It is comprehensive. It is not just for archiving. It does archiving very well. It does preservation very well. But in our understanding, preservation starts right at the point the information is created. If you would like to use the platform also for that, it will also fulfill this need. And finally, we have been aligning it with the most, with the community most recognized and industry most recognized standards in the preservation, in the security and data management field. The exit path is not only possible, but easily done. And yeah, there are no exit barriers at all. So a brief introduction on how this works, the architecture. So you have been able to see that you can use the Amazon S3 storage for the cloud or other types of storage when you are running on-prem. And then we understand that part of the infrastructure is the Kubernetes engine, a database service, and an Elasticsearch service. On top of it, you have the LabDrive stack. In the LabDrive stack, you have different modules that are running there that are going to be basically managing the access to the platform and performing different processes. You may have the web interface, the API servers, the protocol servers. So for instance, you can share the files you have with xrootd and other protocols. So the modules that are in charge of performing these are running here. Jupyter, the functions engine, we are using Nucleo, the validation agents, and so on. So every component in the platform, you have it running as part of this stack. There is one benefit that some customers highlight about this platform, is that if you remove the platform, the underlying storage is keeping everything you need to access your data. So we are keeping the files unchanged, unrenamed. We are not moving them when you are ingesting them. We are not moving them from one storage to another in an old school traditional ingestion process. No, you are directly uploading your content to S3. The platform is processing it there without moving it or creating other unneeded copies, and the data will remain there. So if you remove LabDrive, you will have your S3 bucket and all your data will be there. Your users are able to access the interface in the platform and protocols and so on, but also, as I told you, they are able to access directly the S3 storage. This is extremely convenient. You can use any S3 compatible tool to upload or to ingest content into the platform. And the same for retrievals, and the same for analyzing the data and getting access to it, and so on. So this is something that I would highlight as the most convenient features that you have in LabDrive. So as I told you, the users are able to talk to the storage and internally how this works. So when someone is ingesting a file, they can use the interface or they can use the underlying storage. If they are using the interface is placing those files in the storage and so on. And if users are directly addressing the S3 stack, if you are running in the cloud, the S3 engine is going to create an event for us, for the platform, that is managed by an event dispatcher that is part of the platform. The triggering event, for instance, a new file has been uploaded, is going to check the policy to the container in which this file has been uploaded, and based on that, is going to trigger events for the platform to process. So you may have your custom workflows. You have a default workflow that, for instance, include antivirus scanning for the content, or characterization, or fixity generation. All those things are standard in the platform. So when you upload something, the system is creating in the default workflow is creating 12 different events scan this file with the IB engine, characterize this file, create fixed information for this file, extract the full text for it, validate it in case it's one of the files you would like to validate, and so on. And the platform is executing all those events. So you can see that how this can scale. So this scales to millions of files and petabytes of data, and it has been demonstrated because of this architecture. The result of those events is stored in the database or in the Elasticsearch index, and it could also be received by other processors or the Nucleo engine that is running your own Lambda functions. So, for instance, one of the examples that we did as part of the ARCHIVER project was to extract a tar file that was ingested into the platform. So the user uploads a tar file to the platform, and the platform is extracting this tar file to keep those files independent and not packaged in the original tar file. This could be created in a way. The processing for the archiver was manually triggered in the workflow we implemented, but this could be easily automated, telling the platform to execute this workload when the file is uploaded in a fully automated way. You can have your own Python code running here that is going to perform actions when things happen in the platform, right? So create a new report for me every time I change the metadata, every time I change the permissions, and so on. All these things can be done. So I already highlighted those things. And okay, and an introduction to the data, how the data is organized, how the content can be organized. Due to the degree of flexibility we are offering to accommodate to different cases, this takes a little time to properly understand and properly benefit from. This was highlighted in the ARCHIVER project, in the early days of the ARCHIVER project, and we have been working a lot to rationalize and to improve how this is explained. So in principle, the platform imposes no data structure. Defining the data structure is up to the user and could be done in different ways by different organizations. And of course, different departments, different projects, and different experiments even, right? So the platform allows you to create a structure that could be used this way. So what tools the platform provide you to organize the information? The first one is the archival structure and nodes. You can create a hierarchical structure that represents your departments, represents your experiments, represents the status of the project. You can create the concept of folders and subfolders, and you can keep your data organized in this way with very little or no practical limitations. Then inside those archival nodes, you can create data containers. Data containers are basically a grouping of information that shares similar qualities or properties. So an experiment, or for instance, all the output for a given process, or the whole data set for a department, or just one data set, right? So it's up to you to define what are you keeping in those data containers. But again, it's a hierarchical structure of files, folders, subfolders, metadata, and so on. You can, as I told you, keep files, folders, and so on, and you can keep per item metadata. So this means that for a given file, you can keep your descriptive metadata. The system is going to keep its own metadata, fixity, and so on, but you can also add yours. You can also define different workflows for your content. So the information we have in this node here is going to be subject to this complex workflow when something is ingested, while everything we have in this other node is going to have no workflows, right? And you can define those different policies. You can also have compliance reports. Everything that is in this node needs to use one of those 10 formats, and that's it. We are not allowing for this data set to use nothing that is not A, B, or C file formats or metadata schemas and so on. While in the other container, you could be enforcing nothing and let everyone to decide and to use it in the way they want. So this structure that I have been telling you can be represented here. So you can have your archival structure here, your containers, and then inside your containers you can have files that may contain folders, metadata files, and so on. How you use it is up to you. So our customers are usually representing in this structure here their units, their departments, teams, groups, content types, and then inside the data containers, they are keeping objects, experiment packages, files, and so on. But this is something that needs to be understood in order to basically organize how the archive is going to work. As I told you, and briefly and to finish, you can have default workflows. Default workflows include the unique file ID generation, the integrity for the files, the structural information extraction, the properties extraction, the malware scan, characterization, the packaging of the content, and moving it to the storage you are defining in the container policy. But you can extend them. You can use, of course, this one, which is pretty comprehensive and covers many use cases, but you can also create a workflow in which the platform is going to extract your tars, then is going to validate the bagged files that were compressed in the tar file, is going to verify the integrity of the files, is going to load the technical metadata that was inside a JSON file that was inside the bagged, that was inside the tar file, and finally is going to be creating a report of everything that has been happening. This is an actual example of something that we have done for one of the buyers group in the Archiver project. And you can create your own in the platform. Okay, so, and to finish the compliance reports, so I briefly told you, but the approach in the platform for you to know is that we are adopting simplicity and flexibility as paradigms. So instead of making a metadata field mandatory, the approach, if you would like to enforce for a metadata field to be mandatory, is to create a metadata compliance report that is going to verify how you are aligned to this report. It's not forbidding the user to do something if the metadata field is not there. Of course, you can enforce it as part of the workflow, but the default approach in the platform is to leave you to upload and then enrich. So all those things could be enforced later. So instead of forbidding for the user to upload a certain format, we allow them to upload them, and we allow you to detect it later. Instead of forbidding you the upload of malware, the platform is reporting it, but is allowing you to keep this malware. This has been particularly interesting for some cases of preservation in which you needed to preserve malware there without, of course, impacting anyone on the platform, but you need to preserve it as part of the content. The platform allows you to do that. Okay, so we are 3 minutes late, which is fine, I would say. We have 15 minutes break, and let's reconvene 11:15. Thank you, everyone. Very good. So let's continue with the second part of the training session. So what we are here in the configuration section, and we're going to see now is how you can start applying all those concepts that we have been discussing to the platform, how you can configure those elements to make it work in the way you need. We're going to basically looking first at the user and permissions. In the platform, in LabDrive, everything you can do can be done always in two ways. Can be done using the interface or can be done using the API. So one thing that I'm going to be sending you is the link to the product documentation. I hope this link is visible to everyone. If not, it's docs.libnova.com/labdrive, right? So it's this part of the link. This will give you access to the documentation. We're going to be following it. So for you to not to only know how to perform certain actions, but also where is the documentation for those actions and how can it be performed using the interface. So for instance, for the users and permissions, so we can go to the configuration section in the documentation, and then we can go to the users and permissions. The user and permissions is going to explain us how users and permissions work. We're going to see it now, how accounts can be managed, groups, permissions, and then how to manage them using the interface. So how you can adjust permissions, how you can make users belong to a certain group, how you can provide access to them to the archival structures, and the same using the API. So how you can create groups, create users, and so on and so on. So regarding the user accounts, let's start with the with the permissions. We will go back here. So permissions in LabDrive are managed in three different ways. So the first one is that you have permissions that are defined per application. You have permissions that are defined per node, archival node, and permissions that are defined per container. The result of those is that they combine. So if you have a certain user capable of performing a certain action and the group that it belongs, it's providing an additional permission to do something. So for instance, in this case, you can see the user account has the permission, this one, while the group account has both permissions. In addition, this one, the final resulting permission is combining both. So how this looks in the interface. So your user accounts and groups are here. So you have in the configuration, you have users and groups. So if you go to the users, you can use you can see the accounts we have created. We're working in the third instance right now. Is the Archiver one, is the demo one. So we have the users that we have here, and we can add a new user clicking here. The system will ask us for certain details that include the username, password, the identifiers, and the group that this user belongs to. And then for this user, I'm going to choose this user here, for instance. For this user, is going to allow us to define application level permissions. So you can define if this user should be able to view the containers that you have in the platform, to view the ones that have been archived or deleted, to access the reports section, and then which reports should be available to this user. If the user should be able to change the configuration of the environment, and if it should for only workflows, containers, metadata, and data containers section, for instance, And the access methods, for instance, for accessing it with other protocols, the manual and documentation, performance diagnostics, carbon footprint information, and so on. So this permission, this button you have here, is defining how permissions are assigned to a given application. Permissions are assigned to a given user. The same works for the groups. So if you have a group that contains 13 users, you can also assign the same permissions at group level. You can set those permissions here, and you can also manage what the user should be able to access when working in the platform. So if you go to the archival structure, you can see that we have only one node, which is the non-node. And if we edit it, we can adjust the permissions for different groups. We can tell the platform, inherit whatever was defined for the parent node, or define custom permissions for this node. And then you have a matrix between the groups or users and the permissions for everything that is inside this node, every container that is immediately inside this node. You can adjust permissions so a user is able to create containers or not, read those containers, so basically view them, including the capability of updating the container metadata, deleting the container metadata, accessing anything that is inside the container, but in read-only mode. So now you are getting to the files and the metadata for those files, change whatever is in the container, so be able to write and change what you have there, change the container, change the item level metadata. So whatever metadata is associated to the file, if the user could be changing it or not. Allow the user to manage the storage policy for the elements that are inside the container. So should this user or group be able to move from cold to hot storage or the opposite? This usually involves cost when moving from cold to hot. So this is a permission that allows you to restrict who is able to do that. Purge deleted items in the platform. So this is when you delete something, when you delete a file in the platform, the file is not deleted. It is moved to the recycle bin. So you can always go back there and retrieve whatever has been deleted. With this option, you are giving the user the option to basically empty this recycle bin for this container, right? So if you want for the user to be able to delete things, but not completely delete them, you can enable those permissions, but leave this one disabled. This one is allowing the user or the group to change the permissions for other groups. Remember that this is a very important permission, because if you assign this permission here, even if they have no read access, as they can change the permission, they can change their own permission and include them so they have access to it. This one is going to allow users to understand what other users are doing. So they can see that this has been uploaded, this metadata has been changed, this file has been modified, this file has been characterized, or the A/B scan is positive, or whatever. The run core functions, we have two types of functions. The core functions involved are things for applying metadata in bulk, copy or move content from one container to another. And the run user functions are the ones you can define in the platform and allow you to write your own scripts and code that the platform will execute on your behalf. And the node admin is that if this group of user or user should be able to create subnodes in this node and manage all kind of permissions in this node. This one here is really interesting when you are delegating access control. So let's say you have 3 departments in your organization, and you would like to have one user that is going to be the administrator of this department. You can give this user the node admin right for the department node. And then this means that this user will be able to assign permissions, create new nodes, create new users that have access to this node, and so on, right? So it's basically creating a tenant that others can use. All those permissions could be adjusted. So what we have here is a group, but nothing prevents you adding a group or a user. So we're going to add Tibor, and we're going to add Tibor with these permissions here. If we click OK, so we are going to be adding this user with these permissions here. Of course, you can do it by group and so on, right? You have an indicator of what is each user, with which group each user belongs, and so on. So this is assigned, as you can see, this is assigned to the archival node level, right? So whatever is in this archival node here can potentially inherit the same permissions you are setting for the node. You can organize it this way or not. So for instance, if I have a node here, so in this example, let me show this other side, because we have a more detailed, with nodes and subnodes and so on. So if I have this node here, library and archives, for instance, and we have our containers in this view, if I open a container and go to the permissions here, you can see that this container is inheriting permissions from the parent node, but nothing prevents you to create a custom permissions schema for this particular container. So you can see that combining all these three concepts, so combining the user groups, the node node permissions, and the inheritance of permissions, you can basically create any set of permissions you can imagine with the ones you have available. So you can tell that this user group is going to be able to read, but this user only is going to be able to write, and you can change that for a given container, even if every other container is inheriting permissions, and you can have everything together in the same archival node. For creating permissions, you can also, let me go back here. You can also configure the platform with a federated authentication. You have been able to see that each user that we have is coming with a given identifier that the platform is getting from the authentication, from the identity provider. And in the federated authentication, you can configure this. So in this case, we have two identity providers configured for this platform. We have the insecure accounts creation set to true. We can change this policy. And then we have some policies that are enabled. So when a user is logging in that has certain attributes in the account, the user is made part of a group or assigned a certain permission, and so on. And you have the logs of whatever has been happening below. So you can also debug the authentication yourself when you are adding your own identity provider here. In the same way, I can create a user account. If I go to the configuration group user and click add a new user, I can do the same using the API. So if I go if I configure my, for instance, using curl, but of course you can use anything else. I'm using this endpoint API user internal. I'm telling it to create a new user with these properties. So if I execute this, the platform is going to create a new user account for me, right? So with this ID and so on. And in the same way, I can assign policies, permissions, and so on using the API. Everything is documented in this article in the user and permissions one. So you have For instance, for user accounts, well, here it is explaining the process we have been following, configuration, user accounts, groups, how this is configured, application permissions, so everything we have been looking at. In the configuration archival structure, you can set permissions to access it. And then you have the API, in which you can have the API to add, to create a new group, to create a new user, to make a user belong to a certain group, and so on, right? So to see the permissions for a given user, or the permissions that are available, and so on. And here you have all the documentation related to how this is integrated with a SAML identity provider, how the configuration is done for the automated account creation, permissions, and you have also how this is managed. So when you are logging in the platform, you can click in your identity provider. The system will allow you to choose your identity provider, and finally will log you in the platform. We have compatibility with any SAML-based IDP, and we have also integrated the ACR Active Directory for allowing users to log into the platform. Okay, so we have been able to see groups, application permissions, content permissions, federated authentication with automated account creation, the permissions, permissions audit with effective permissions, users, and the security audit. We have, so if you have 10 users, managing the permissions is going to be extremely easy. But if not, if you have a few thousand, then things may get complex to understand how permissions are organized in the platform. To do that, you have several permissions that you can use to analyze. So you have here the effective permissions audit that you can run, and you can see basically for each container which groups or users have which permissions, and the system is highlighting things that are not aligned to the that are not inherent, right? So in which may represent some risk or may represent something that you would like to look at. You can have this report here, but of course you can also export it. Any report can be exported, so you can have it here, and you will have it is now generating, but it will generate a CSV file with all this information. Part of this report also, part of these reports also you have the security audit that is going to be basically telling you everything that has been happening to the in the platform. You can filter by method, by date, by user, so to basically locate what you are looking for. Here you can see that the administrator, I'm running as the administrator right now, made an access, a request for the file metadata for this given object with this IP address and so on. So, and you can, as you can see, if I search for something, or in this case, it is telling me that I created or removed this user. So everything that I do in the platform gets retained in this log. This is very good for compliance and security audits and so on. This can also be exported as a CSV file. And we have the third report related to this is the security audit. No, security audit is the one we have just been able to see. We have another one. Let me see. Probably I'm wrong. I can't find it right now. It's probably one of these that allows you to see what is the policy, storage policy per container. Is this one that allows you to see the storage policy that users are applying to the container for every container you have, who has been changing it, and so on. Okay, this is related to the permissions. We have been able to see it. you have a better explanation on how everything that they have been explaining. We will provide those slides, so you will have access to them, so you have additional information. So now that we have been able to see about the permissions and permission schema, let's see how the archive nodes are configured and are managed. So when you go to the containers and containers by archival structure, you can see the whole archive structure, of course, if you have permissions to see it. So let's say that I'm logging in as Alice, and Alice does not has not access to hasn't access to see this node here. So this node will not be displayed in this screen, right? So C would be unable to see what they have no permissions to see. So in this archival node is how information is structured and how you maintain it. You can go to the configuration section, archival structure, and here you have your nodes and your subnodes, right? So you have the same structure you have in the previous view, but here you can change it. So let's say you would like to add a new node. You click in the add a new node. You can provide the name and so on. You can for the node, you can include the container quota for the containers that are going to be included in this archival node. This is one of the last features that we added a few days ago or a few weeks ago as part of the ARCHIVER project, the container quota management. So you can set the quota, the maximum quota you would like to have for everything that is going to be, every container that is going to be inside this archival node. Here you can define the container templates. So you can, using the container templates, you can enforce certain policies for all containers that are created in a given container. So in principle, when you are creating a container in an archival node, the user that is creating the container can choose, for instance, the metadata schema that is going to be used for the container, that for the content that you have that you're going to have in the container. If you would like to prevent this, you can use the container templates. So here I'm letting the user that is creating the container decide, but I could enforce the use of one template that in this case is the new template. This is one of the templates that is created, that is enforcing a certain metadata schema to be used of a certain type of data structure, or for the container to be pre-populated with a certain data structure. So for instance, you may be creating a template for every new project. Every new project is going to have 3 folders. One is for the working folder, the second one is going to be for the final results, and the third one is going to be for the documentation. And in the first one, we have 3 files and few folders with a data structure, and this metadata we would like to be there, and so on. You can package everything in one of those containers, and you can make this the default template for new containers that are created in this node. And if you assign this to the, I don't know, new projects archival node, when the container is created in this node, it will be pre-populated with certain data that is your template for it. And then you have the permissions that we have been able to see. You can tell the platform to inherit them. As this has no parent, it can be inheriting permissions. But if not, so you could be inheriting them, or if not, you can set custom permissions in the same way we have been able to view previously, right? So it's this is for creating them. For editing them, it's exactly the same. You select the one you would like to edit, you click in edit node, and you can change everything that we have been looking at. That this will be consider for new containers that are created, and in some for some of them for existing containers, existing policies, and so on. But this depends on how you have created them. But this is easy to basically manage this structure. One thing you can do, I'm not explaining it to you, but you can make a node you are creating a child of a given parent node with specifying it here. So if I'm creating the node XXX and I would like to make it part of the mathematical, physical, and life sciences node, I just need to do this. And everything else is updated. So yeah, you can inherit them and so on now. So this is basically to create more complex metadata structures. Everything that I have been telling you, that how to create those archival nodes and so on, is defined in the archive organization section. This is explaining you how files, folders are structured, how this archival structure can be organized, how to manage it, the one we have been looking at, so configuration, archival structure, your nodes, creating them, editing them, and so on, and of course, using the API. So if I would like to create a new archival structure, I can get this sample code, I can copy, I can paste it in my terminal, and I will be creating this archival structure. I don't know if this will fail or not, because I don't know if I have the parent ID or not. Yes, it has worked. So now I'm creating, using the API, using the API archival structure, using a post type of request. I'm creating a new archival node, that is new archival structure with this code and so on. And the system is answering me back the policy that this container is going to have, its identifier, and so on. If you go now to the interface, you refresh it, you will see this new node that we have created, new archival structure, which is the child of the number one, which is the one that was there, and this is the one we have created, right? So you can see that everything in the platform can be done in an automated way using the API or using the interface. Related to the next element, that are containers. Well, you have been able to see how the archival organization is created, but as you remember in the archive organization, here we have this diagram. As you remember, this part we have been looking at is this bluish structure, so the collections or archival structure part, and inside one of those archival nodes, you can have one or many containers. How this is done, you can go to the archival node that you would like to create your container, and you can create a new container here. What you're going to see next depends on the permissions and on the templates and the configuration you have been defining. As this archival node is allowing me to create any sort of policy, template, metadata schema, and so on, it is allowing me to select from the ones that I would like to select. But if you have a template, if you have a policy in place, this policy is going to prevent you to choose from some of those options. You can force 13 containers in 13 areas to have 13 policies. So those boxes would be unavailable and pre-selected. So the first thing is that the system will ask you for the container name. The container name is the one that when you are looking at a given archival node, for instance, if I'm here, the container name is this one, right? So I have it here. Next, we have the container description, which is the one that is here. Next, the system is going to tell me where this container is going to be. By default, it's in the same node that I have selected, but I can change it. If I would like to use a template, it is going to allow me to select a data container template and also a content template. You have this explanation I gave you about the content and so on. You have it here. The metadata schema that you would like to use for the container and the metadata schema you would like to use for every item inside this container. The container is, if you think about this system like a container, for a container like a box in which you are placing things inside, the container metadata could be the label you could place in the outside of the box to quickly and in a fast and efficient way recognize whatever you have inside. So if you decide to use containers to keep your projects, for you, one project is going to be one container, for instance. So this would include the name of the project, for instance. So those are, in fact, the name of the container is the only required metadata for a given container. Everything else is up to you, it's optional. You can use 100 fields or you can use none. Of course, as you know, the better your metadata, usually the better your and the easier your preservation will be. So I can choose, for instance, the metadata schema. So I can choose, for instance, the research projects metadata schema. And for the items, I can use the Dublin Core metadata schema because I would like to use just a set of Dublin Core fields there. Where are those metadata schemas defined? You have them if you go in the configuration, container metadata schemas and object metadata schemas. In the container, you have the metadata schemas you have at container level. So this one is the one that I selected. If you open it, you can see the metadata fields that you are going to have available and each type. So I can quickly add a new field to this metadata schema and tell that this is, for instance, a value list, and the allowed values is value 1, value 2, values, and value 3, right? So this can be done. I'm going to cancel it, but you can create this additional field that would be part of your container metadata schema. And the same goes for the object metadata schema. So every item that is inside your container. So as you can see, I am choosing the Dublin Core, and the Dublin Core is already created and has these few fields. But you can also, in the same way, extend it on your own. You can import and export metadata schemas in XML or JSON format. So if I would like to export this metadata schema as a JSON file, I can quickly export it or import my existing metadata schema quickly to the platform. So you can see how fast you can create those for your content. So this is selected here in the container and in the item metadata schema. Next, you can define the workflow that this content, the content that is going to be flowing to this container is going to be subject of. You can use no workflows at all. You can define your own workflows, and those workflows are going to be a set of steps. Those steps in the workflow could be human, I would say, managed, or could be system managed. The human managed ones could involve certain steps that you would like to follow for this container. So for instance, if you would like to create a workflow for publishing your content in Vimeo, for instance, you may want to add a workflow with 4 or 5 steps to initial status, metadata, add metadata, remove unneeded fields, set rights, and so on. So those steps are usually based for someone to be able to be moving the container from one status to another. But those status in the workflow could also be system managed. So you could have a status of one of the steps of your process in which the system is going to extract a tar file, or is going to run a Rihanna workflow and produce certain files that will be part of the container. So each step of the workflow could be one or the other. And as you can see, using this piece here, you can basically build any workflow you can imagine, as you can combine human assistant processes with system code that is going to be executed. You can create any kind of workflow. Those workflows could be in the same way managed using the interface. You can let the user advance or go back to the status, to a step of the workflow, or you can use the API to move containers from one status to the other, checking which status they are, and so on. The code that the platform is running is also capable of reverting back to a previous step, moving to a next step, and so on, right? So this is the full workflow capability. As I told you at the beginning, nothing forces you to have a predefined workflow. You can choose to have a workflow or to use the default one that is going to include all these steps that I told you, basic things. And as you can see, nothing prevents you to have a container with a very deep and complex workflow, and the next one would have no workflow at all. This is one of the best things of LabDrive. You can choose inside the platform. Next one is you're going to see the assigned storage type. With LabDrive, you have one huge benefit, is that you are getting some sort of abstraction over the storage you are using. You are going to continue being able to search for the metadata of your objects, open them, retrieve them, no matter what is the underlying storage technology that the platform is using. So in this case, you are telling the platform that the storage type you would like to use is the standard, is the S3 standard, but could be from another a cloud provider. For now, we have only integrated with Amazon, or could be your storage provider, and so on. And then you have the storage class, which is the storage class that the system is going to use for keeping the object by default that you are moving to this container. So here we have, in this instance, I have the standard S3 and the Glacier Deep Archive storage types. And this is managing in a, this seems to be simple, but there are many hidden things when using call types of storage, because you are basically paying to access this storage. So you don't need, you can't directly upload to Deep Archive and then do all this expensive processing of reading the file to generate the fixity, extracting the text, and so on. All this complexity of having the objects in a hot storage while the object is processed, and by the end, moving it to the Deep Archive, is handled by the platform. So if you specify for this container that the default storage for this container is going to be Deep Archive, at the point you upload something to the platform, you are of course uploading to the hot storage. The system will trigger all those processes that needs to be performed, will trigger all the processes that you are telling the platform, your custom workflows or functions. And when everything has been finished, the system will initiate the process to the transition process for the hot storage to the cold storage, and will finally verify the integrity of the process to verify that everything that is reaching Deep Archive is exactly the same hash, has exactly the same hash than it had when the object was uploaded. All these things happen without the user noticing, right? So you upload and you forget about it, and the platform is taking care of it. The check-in and check-out functionality. Some use cases demand that only a given person is working on a given project or data set at a given point in time. So this is the check-in and check-out policy. You can tell the platform to allow or forbid more than one simultaneous user to access one container. By default, it is disabled, so you can have 100 users accessing the same container at a given time without any problem. If you enable, they will need to check in to be able to access, and for anyone else to be able to access the container, the user will need to check out to leave anyone else using it. And then you have the container quota that, as you can see, can be defined not only at the node level, but also at the container level. So I'm going to set this here. Okay. I'm going to create a container, and my container has been created. This is the view for the container 50, which is the one that I have created, that is part of the archive research projects. Now that I have created it, I have an overview about the files that I have, the size. If I have additional metadata, I can see it, and so on. This is displayed in this section. Next, you have the active content analysis. The active content analysis is really useful, and it's going to basically warn you about potential problems that you may have in the data that you have in the container. This is part of the active content screening technology that is embedded in LabDrive, which basically is analyzing the content as it gets in. So one thing that the system is doing is calculating, so verifying the content for viruses. We have a malware scan in the platform, but the malware scan is not only detecting viruses per se, it is also detecting potentially unwanted applications. So let's say that you have a PDF file, and the PDF file has an executable file embedded. This is not per se a virus, or may not be per se a virus, but it's a potentially unwanted thing in an archive. It is something that is hiding something else from the clear view. So if you do that, this would go red, and the system would be telling you that in this particular file, the system is detecting a potentially unwanted application. We are expanding this to many other areas. So for instance, we are now implementing a zip bomb detection. So if you are uploading a zip file that contains many recursive folders and so on, now the system is not processing it, but we are also improving the logic for the system to be able to detect it and warn you about those kind of potentially harming things that are not per se viruses and so on. So we continue extending this. Next is the unknown formats. When the system, we are implementing several characterization engines in the platform. A characterization engine is part of the digital preservation planning. In the preservation planning, you basically have several risks. One of them is the obsolescence of the file formats, for instance, and to be able to protect the data to the format obsolescence, there are certain activities and processes that you can execute. One of them is, and that is relevant, is understanding the file formats you have. So this is characterizing those files, and when it finds something that can't be characterized, the system is telling you that it can't be detected. The format can't be detected. This may be fine. You are using some obscure format. That's fine, or not. You are this should not happen. Why this is happening? And this would allow you to detect, for instance, encrypted content that is being uploaded to the platform. So this may be fine. You may have a valid reason for uploading encrypted content, and the platform will work. But as the platform is unable to know what is inside, is unable to know the file format of the file you are using, it will also warn you about a potential dangerous situation, and this box will go red. And this one is for creating, for getting duplicates, for instance. So this is again something that you may have a valid, a legit reason to have duplicates in your archive, but the system, if duplicates are detected, it is also going to be telling you. Next, you have the workflow. I have a very simple workflow here, and next you have your metadata. You remember that in my metadata schema, I had these 5 fields: research, project name, starting date, project notes, this that I would not know how to pronounce, and this new name file field here. So you can fill those values and so on. So this is describing your content, the content you have inside the container as a whole. In the explore content, you have this kind of file browser that allows you to create folders, to create files, to upload or download immediately from here. So it's basically everything or most common things you can do with a file browser, you can do them from here. Let me show you a container in which I have some files for you to see how this looks in a real case scenario. So I have several folders and I have several files and so on. So I can right click, create a new folder, for instance. So I can create it, I can open it. I can, if I have some files in my computer, I can drag and drop them to the immediately to the platform. Of course, this is not valid for more than 3,000 or 4,000 files. There are better methods for uploading files here, but it will work really good for even large amounts of files or even large files. So for small things will work really well. You can copy, you can select, you can right click, copy, you can immediately download something that is here and you have it in your browser. So this is really handy for managing the content you have. In this view, we are embedding nearly 300 format viewers as part of it. So let's say you have a JPEG 2000 file. To open it and to preview it, you can just double click and the system will open it. The same goes for other file formats, PDFs, Office, multimedia, medical images, research, some research formats and database formats. We are extending it to new formats that we are requested for and so on. Those viewers could also be extended by the user. So let's say you have a format that you use and you would like to have preview support for it. The platform allows you to build a plugin for a viewer of the format and include it in the platform. So when you double click it, it will open. In addition to being able to open them, you can also see or change their properties. If you click in this file and click properties, you are going to have, for instance, the characterization results, the creation date, the hashes you have defined to be generated on ingest, depending on your workflow, the metadata that is going to include the metadata of the schema you have selected, or the embedded metadata that the system is extracting from this file, the events, what has been happened, the storage in which this file is, and different versions that you may have for the same file. If you overwrite something, the system will retain previous versions and allow you to recover them. Of course, it will, if you have the proper permissions, will allow you to remove all previous versions. So this is related to the content. So you have also the possibility of searching. So if I search here, it is capable of locating it in the metadata, in the content, in the file name, in the file path. So, and of course, in the metadata you are providing to the system. Well, I forgot to tell you that you can import or export metadata in CSV, XML, and JSON format, but you have also an interface to apply metadata in bulk to your own data structures. So you can, for every object that I have selected, for the metadata field description, clear all existing values. And then for the title, add a new value, which is going to be this one, and so on, right? So you can also apply metadata in bulk. You can apply metadata you have in a JSON file, for instance. You can apply metadata you have in Excel. We have code samples. This is done using a Jupyter notebook, for instance, that assigns metadata to the objects reading it from an Excel file. So it's very easy to integrate with other data sources and so on. This is search. This is permissions. It's again the same we have been looking at. You have reports. You have plenty of reports you can get of the content you have in a given container. You can also share certain folders publicly. So let's say that you have, as part of as a one container, in one container, you have some files that you would like to share with someone else without needing authentication or a platform account. You can share an individual element. You can share a whole folder and so on. And unauthenticated users will be able to get access to this file. This has been done in a very in a smart way. So when you are requesting a file, a share file, the file is not flowing from the storage through LabDrive and send it to the user. The file, the platform is getting the request, is verifying that the file has been shared, is creating a pre-signed URL, and is redirecting the user to this pre-signed URL, which is, and if you are using S3 as your backend storage, is an S3 URL. You will see that this will allow this to immediately scale to anything that S3 scales. So this file may be published, and you may have thousands of users concurrently reading it, and you will get a really good performance for each of them. So this is one of the benefits of this process that has been implemented here. In the action log, everything that is done in the container is retained here. So for instance, you can see that I open the preview of this file. I downloaded this file. I opened this, I created this folder, I uploaded those files, and so on. This can be exported as a premise XML from here with all the events that have been happening for this container. You can, of course, download only the ones for a 13 file object and so on, but those are container-wide. And those are the functions that I will explain you later that have been executed. And here, the storage and integrity, you can see how the system is managing the integrity, what is the frequency in which this content, the integrity of the content is verified by the platform periodically, and so on. So you have all the details about the integrity management there. So containers, concepts, overview, metadata storage, introduction to metadata and metadata configuration. We have been able to see all of them. Okay, so we are a bit ahead of schedule.
Yes, we are. Antonio, there are 3 questions in the question and answer.
Very good, thank you, Theo.
So you can answer them this time, and then we can, since you correctly stated that we are ahead of time, we can take an early break.
Very good. I will answer those questions.
Okay.
So for the first one, we're getting a question on which level is the archive map to the S3 bucket level root of the archive. You have every container can be potentially linked to a one S3 bucket or not. This is your decision. For now, we are keeping, so in this platform I have here, every container is in the same S3 bucket. But this does not necessarily need to be done this way. You can, for instance, have two containers that you would like to have in two different geographical areas. You would like for one to be in Europe and another one to be in the States, for instance. The platform allows you to do that. You see them in exactly the same way, right? So you see two containers in the platform and the underlying storage is in two completely different regions. So it's up to you on which container, in which S3 bucket each container is going to be. Inside each S3 bucket, the same files and folders structure that you have here is represented inside. So after the break, I will configure the S3 client and I will be showing you this file structure. But basically, if you open the bucket, you will see a folder, this name 5, and inside the folder name 5, you will see one that will be named 00 formats, and inside this folder you will have 4 subfolders, each of them with its files and so on. So it's retaining the same structure you have and the same file naming you have. This is extremely convenient on accessing the content. Alfred is asking us, how much simple or complex can a workflow configuration be done? The simple is that the simplest workflow is no workflow at all, which is already there. So you have the bare minimum one that the platform needs to work: fixity, A/B scan, characterization, and so on. This is the one that is already built in, and you need to do nothing. So for you, you don't see it happening. So the platform is doing it because the platform needs to do it to fulfill its the way it works. But for the workflow, you can configure. We will see it later. But you can create a set of functions for to be executed for more of one of those functions for the same step in the workflow, or one function for the whole workflow. Is up to you on how to organize it. But at the end, you have Python code that is running. So in this example, we have some Python code that is running some things in the platform. You have an abstraction library, which makes the development much easier in Python. And yeah, it's Python code. So how complex could it be? As long as you can code it in Python, the complex you would like for it to be. We're using Python and we're building everything on Python because we think that this is something that is highly aligned with this community. But the architecture allows us to, in addition to Python, to execute code in other languages. So we have, for instance, Java, we have C, we have also C# supported, and we have like 2 or 3 of them, 2 or more, because we are using a component that is able to execute several code in several languages. So how complex? Up to you. So you can make it as complex as you want. Another question from Alfred is, if you improve your workflow later, is there a possibility to repeat steps in the improved way for the intellectual entities which has been ingested in the past? Absolutely. This depends on you. So this could be you could need to design this workflow in a way this can be done, but in the application at the application level, you have everything you need to detect this. So for instance, we recommend, this is part of the extended training. We don't have time today for going deeper into this, but we recommend for you to use the metadata field to describe the type of object you have for a 13 data structure. So this way, your code could be, if the object is this type and the class of processing is workflow version 1, then process it with the version number 2 of the workflow and update the metadata field of process with workflow number 2, for instance, right? So you have everything in place. We would need to discuss a little bit on what is the best or the preferred approach for it, but there are plenty of tools for managing extremely complex workflows. And this is just using the built-in Lambda functions, the built-in functions. But as you can run snake-make code or Rihanna code, if you have a C++ code that does something to your data and you would like to execute it as part of the workflow, we finished it yesterday. The implementation is also part of the ARCHIVER project. We are combining the functions and the Rihanna integration. So a function can call a Rihanna workflow. So you can make the platform to, when you upload a new file, a C++ code as a Rihanna workflow to be a Rihanna snake make and so on, workflow to be executed and to get the results back to your container. So you can do almost everything. Richard is asking us, can this solution be integrated with a Dataverse? In theory, it can. The API is fully aligned. We have not had any customer that has requested this integration yet. But the principles, we know very well Dataverse because another of our products is already integrated with Dataverse. So everything has been created to allow this integration. But yeah, we have had no requests for this integration so far. Okay, so as we answer all open questions, we can have 15 minutes break, or at least a bit less than 15 minutes. So let's no, a bit more than 15 minutes, sorry. Let's reconvene here and 10 past 12. Sure, 10 past 12, that's correct.
Yeah, that's correct.
Very good. Thank you, everyone.
Thank you.
Can you hear me, Theo?
Yep, perfect. There was a question again from Richard that was left out from the last part of the session about integration with Dataverse, the product that you mentioned that has been already integrated, or we have used the API to use to make this integration.
Yes, we have several product lines. So basically, LabDrive is the one we are offering for research-related organizations, but we have other products in the cultural heritage, academic communities. One of those is LibSafe, and this is the one that has been integrated with Dataverse. If you have more, if you'd like to understand more details about this integration, you can request it. I will provide my email address, and I hope you receive it in the chat, so you can send me request, and we will provide more details or show it to you live if needed. Okay, so then we have the third block of the training, which is going to be basically understanding in a deeper way how to create containers, upload and download content, searching, accessing it, and so on. So what we're going to be doing is we're going to see how every process is done with the API and with the graphical interface. I'm going to be pointing in the same way, and I have done at the beginning. I'm going to be pointing you to the documentation so you can improve your understanding of the platform if you are interested. And yeah, we will do it this way. This section of this block of the training is going to be until here. So the functions and workflows is for the next one, right? Okay, so creating a container in the platform, you have been able to see how containers are created using the interface. You have in the documentation, you can go to the get started, create data container, and then it explains you how to create one. So you go to containers, new container, you specify the values as you have been able to see in the previous block, and then the container gets created. You can do the same using the API. When you are creating a container using the API, you will need to be telling the system the same values that you need to provide when you are creating it using the web interface. So if I go to LabDrive and I click containers, new container, the system is going to ask me for the node in which I'm creating this container, and then the metadata schema, the policy, and so on. Everything will be encoded as part of the request. So let me quickly show it to you. So one thing that if you are, well, I forgot to tell you that you can request sites for evaluation. So if you are interested in LabDrive, you can request an instance and we will be deploying it for you. We will be providing you basic training. In addition to this session, we have other training programs for you to get familiar with it, and then you can play with it. This is, of course, free of cost. So one thing that we recommend is that you set the global variables, your platform URL, if you're going to be playing with the command line and curl and so on to get familiar with the API, for you to keep this environment variable and this environment variable with the ones that the platform is going to provide you in the access methods. Here, when you go to administrator and you click in access method, I'm not going to open it, not to reveal my credentials, but if you do, you can see your own credentials here. Every user has an API credential. This means that when you are using the API, the security model is inherited to your request. So if you are searching for something using the API, you are going to be able to see only you have access to see, or you're going to be able to perform the actions you have rights to perform. Here in the access methods, you have also the S3 configuration. So if you are using S3 for the storage, you have the access key and the secret key that you can use to configure your S3 protocol. Those credentials are unique, are only for you, and should not be used for sharing files or for external code and so on, and unless you want for the code to have access to everything you have access to in the platform, right? So, but you have all credentials for all protocols you have enabled are here in this section. So what I recommend is for you to save them as those variables and so on. This is of course assuming that you are going to be using curl to get familiar with the API. If you are going to use Python or whatever, you have a Python library that you can use. So you can see in the configuration, data preservation section, and then you have developers guide. In the developers guide, you have in the extended documentation and functions, you can find this how to code a function. Yes, Jupyter notebook documentation. You have this Jupyter library that you can use to interact with the file system, the API, S3, and so on. So you have many things to be able to access everything you have in LabDrive, assign metadata, remove things, and so on. So the most common things you can do are in this library. But if you are going to, like in my case, if you are going to be using them curl, I recommend for you to create those two variables and assign values to them. So creating a data container. When I'm creating a data container, as you can see, I need to know, for instance, the container metadata ID to use, or the metadata schema to use for creating this container. Below this, you have the examples of how you could be calling those endpoints to get the information you need. So for instance, if I'm interested in understanding the container metadata schemas that I have in the platform, I can get this. I can go here. I'm sorry. And then you can see that the system is telling us that we have 5 metadata schemas. The number one, the ID one is empty schema. The number 2 is submission schema, 3 research projects, and so on. If you go to the interface and you go to the configuration, container metadata, you will see the empty, submission, research project, and so on. So the same you see here is the same you get in the interface. In fact, the interface is calling this endpoint to retrieve this information, right? So you're going to be getting the same. So this is for the available container metadata schemas. But what about the object level metadata schemas? Well, exactly the same. You have this other method, objects metadata schema. So you can see containers metadata schema, and in this case, it's objects metadata schema. So you go here and you get your containers metadata, your items metadata schema, demo schema, and so on and so on. For each of them, you can ask for the fields. You can create new fields using the API, and so on. Everything is part of the documentation. So when the same for the workflows and so on. So when you have when you know the IDs of the elements that you are you need to create, you can finally request the platform to create the container. So so we're going to be creating it. For instance, we're going to be creating it. This will work. The archival structure ID is the number 1. So we're going to create it in the node number 1. So when we create this container, the system is going to be telling us that, yeah, the operation has been successful. I have created the container with ID 51 with the descriptive information you have provided. You have the policies that the system is applying, the unique identifier that the system has created. If public access without authenticated access is allowed, so if this container is publicly accessible without authentication, the quotas, and then you have the permissions. So you can see that the user permissions that have been defined are those ones. You can also change those permissions using the API and so on. And below you have the storage class. the storage class is telling you, you have created a container according to the policy that we have defined in the system. This has been created in the Amazon S3. So the storage class ID is the number 1. The storage class should be applied immediately, so starting immediately, because we don't have any scheduled transition plan. And the bucket, the S3 bucket we are keeping is this one. The region of this bucket is I think this is Frankfurt. The tenant, so the owner of this bucket is your instance. So this is the lab drive instance that is executing these tenants, and this is the endpoint, and so on. And here you have some advanced policies and so on. If I go to the interface now, you will be able to see that as in the node number 1, we should have a new one. Probably the last one. Yes, my container, archiver, some fancy description, and so on. So we have created this container using the API. The same details I'm getting when I'm creating the container, you can also request the details for a given container, and you will get basically the same. You have other methods for interacting with those containers. If you go to the API extended documentation here, you will see the full list of API methods. And then for containers, this is the area for containers. You can create with a post request a new container. This is what we have just done. You can get the container details. You can update it. You can delete the container in a permanent or non-permanent way. You can restore, you can check in, check out, upload things, run functions, create folders, change the lifecycle policies, change the metadata, change the permissions, use the workflows to move one step back, to change the index to the next step, and so on. Get all existing containers if you would like to list all of them using the API. Get the logs, get the data file for a given file path, or get the statistics, update the number of files that you have in a container, and so on, right? So everything that can be done in the container is in this part of the documentation. Uploading and downloading content from the container. You have basically 3 ways to upload or download content from the platform. The first one is using the interface. The interface here. So when I open a new container, so let me open this one, for instance. As I told you at the beginning, you can drag and drop files for them to be uploaded. Right, so I may have a photograph here. I can upload it to the platform, and that's it. I have uploaded it. What the system is doing under the hood is basically placing it in the storage. So this file is managed by the browser. The browser is sending it to the web interface. The web interface is saving it in S3. So this is what has been happened when I uploaded this file to this container. As I told you, this is fine when you are uploading a few thousand files and so on. This is going to be fine. The limits on when uploading using the browser or not, they're not fixed limits. But the thing that is always important to consider is that all this is managed by your browser. The platform is not creating any bottleneck here. Your browser is. So when you are selecting 10,000 files and drag and dropping them to the browser, your browser will create a data structure for each of them and so on, and will need to process each of them, which depending on the memory you have, the computer you have, and so on, may be slower or not. So this depends on you. As a rule of thumb, as a recommendation, anything around 3,000, 4,000, 5,000 files in almost any computer out there is going to be fine. It is not important. It's not so important the size of the content as the number of files, right? So if you are uploading 1 terabyte of data and one file, this will work fine. If you are uploading 1 million files and 1 gigabyte of data in all of them, this will go much slower. So you have other methods for uploading content to the platform. The next one is using the API. You have an endpoint for uploading an API to the using the API to upload it. This is again not recommended because you are using the API, so this scales worse than the third method, which is the one recommended, which is using the storage directly. One of the as I told you, benefits of the platform is that you can directly use the S3 storage that you have under the hood. So how can this be done? So if we go to this bucket, for instance, to this container, sorry, we have the container number 5. If we go to the storage and integrity, we can retrieve all those details using the API, and I told you, but I'm going to be showing it to you using the interface. You have the bucket, you have the folder, and you have an example. This is using the official Amazon S3 CLI tool on how you can copy one file that you have on your computer to this bucket you have here, right? So let's get this second part, and let's go to the command line. So I have already configured the CLI tool to work with the credentials that I obtained from the access method. So if I, for instance, try to list whatever I have in the container number 5, you can see this is the bucket and this is the container. So you have all the folders and that you have in the container, and the files and so on in exactly the same way, sorry, that we have them here in the Explorer, right? So you have all those files and so on, and you can open and access them in exactly the same way. So let's say I would like to create a new file and upload it to my container. So this is all understanding that we're going to be probably scripting this or not doing this manually like I'm doing it, but just for demonstration purposes. So so I'm going to create this file, and we are going to be S3 copy. The file is file 2, and the destination is the one we included here, but we're going to name it my file 2, right? For the first file, this takes a few seconds because it's initializing many things under the hood and so on. But when you are uploading, in the case that is usually done of uploading multiple files, this is rather fast, and I will be telling you interesting things. So now we have my file 2 here, and we have its content, right? So we have uploaded it. Under the hood, without us noticing it, the system has been able to characterize it, has been able to perform the various scan, has been able to index it, extract the text, make it searchable, extract any technical properties that this file may come with. The txt file is going to be nothing, but if you upload an image or a database or whatever, there are many embedded metadata fields that the platform would also be extracted. And you can see that this has happened without me to need to run any workflow, perform any complex operation. Just by uploading something, the system is processing it. You can always understand what is happening in the data analytics, performance, and diagnostics. In the performance and diagnostics, you can see everything that is happening in the platform, the events that are pending to be processed, and how the platform is working, and so on, right? So you can understand what is happening there. I don't know if I can show it to you now, but all the logs and so on are all gathered by a Loki instance and are consolidated in a Grafana environment. So all the logs of everything we are doing, in addition to most of them, for us to have them as part of the action log that we have also them in a blog format that could be used for other purposes if needed. Downloading files is exactly the same. So you just need to tell this to copy this file to your, so it would be, so we would be copying this file here, and we're going to be copying to the my computer, and then we have our file back. This is, as I said, the recommended way of uploading and downloading content. I'm now using the CLI tool. This is the, when you are using CLI, I would say the recommended tool, and this is incredible, good and capable. So it is running parallelized transfer, not only for multiple files at the same time, but also for multiple parts of the same file at the same time. So in the upload and download exercises, we used this CLI tool, and this is the one that we scaled to 500 terabytes a day. And we probably, without any trouble, could double that in the network transfer way. If you have enough throughput on your network, the S3 endpoint is not going to be the limit, right? So it's you can move massive workloads to the S3 platform, and then the platform will process those events as they come, right? So it may lag 20 minutes behind your transfer when you are uploading several million files, but it will also be processing all those files, scaling up, scaling down, all those things that I have been telling you at the beginning. When you have your content into the platform, you can download it in the same way that we have done here. You can download it from the interface. So right click, click download, and you get your image, right? So you get your photograph, and you can also publicly share this file. So if I select this file, it is telling me that this file is not shared, but I can share it publicly available. So if I click share, the system is creating a public share link, right? So which is I'm going to open it in a new tab. As you have been able to see, it has downloaded it, right? So if you use this, or anyone is using this link in the platform, they will be able to download this file without needing to authenticate. You can also share folders in which the system will present the interface, so users can download and access any file that you have in the published folder. You can also download multiple files in a single process. So if I select multiple files and I right click and click download, the system will create a zip file for me that will include all the zip files that I have selected, including subfolders that I may be selecting, right? So this is another way of downloading content from the platform, which moves us to the next section, which is searching. I told you that the system, for every element you have, every item you have in the platform, is retaining different kinds of metadata. So for instance, for this JPEG file, we have here, the system is extracting all the embedded metadata it is finding, and it's indexing it. Additionally to that, the second type of metadata is the one you provided to the platform, your own metadata with your own schemas and so on. You can categorize it, etc. The third type of metadata is the content. So if you have a PDF file, for instance, like this one, all the text you have in the PDF file is recognized by the platform, is extracted, and is indexed. And the fourth type is the file name itself. So the file name and the file path that could also be used for searching. When you would like to search, you can go here to content search, and you can basically perform a basic query here, and you can restrict what are you searching for. So by default, everything is enabled, but you could decide if you would like to search only in the metadata you are providing, you would like to search only in the full text content of those files, in the metadata that the system is extracting, or in the file name and path. And you can also filter by department, structure, project, or whatever. However you are using those archival structures, you can filter based on them. Then you just need to click enter. You can see we have a fairly large amount of files and content here in this platform, and you can see that our search results are 116 milliseconds. So the platform we have been working a lot to optimize this. Even for really large collections, you will get consistent times, right? So the platform is really fast. So you can see that here it is finding one result. This result is in the container 08 test, this file path, this file size, and it is giving me the match in the content that includes the words that I'm searching for. As you can see, we have fuzzy search by default, and so it is detecting also changes on the word and giving you results. In this case, you can see here for this file, it is finding it in the content, but in this case, it is finding inside the embedded metadata, it is finding in the resource name, it is finding this value, right? So this is another type of search. You can also facet your search. I'm not telling you, but you can tag your content. So you can add tags to your elements, and you can filter them based on those tags. This is really useful for when you have some kind of, you would like to implement some kind of change control to understand what is ready to be published, what can be made public, what can't be made public, and so on. So you can use those tags to create sets of content. So you can, if the files you have, any of them has been tagged with any tag, you can filter it by here. You can also filter by formats. So I would like to see only the matlib, whatever, or the C code, whatever that contains this word, right? So this, as the C code is text and is indexed, you can also search for it. You can also face it based on containers, only in this project, only in this department, or whatever, the file structures and the archival structures, and so on. When you have identified that this is the element that you are interested in, you can click in open, and you will go to the container in which this file is, and the file will be highlighted here. So you can double click and open it. So this is a document, I'm finding this word here. From here that I'm now, I can also perform other searches, right? So reflected, and then it is finding it in the text. I can perform basic operations and so on. And for some file types, you can even apply real-time format conversions. So for instance, let's go back to the container we were in previously. So it was manuscripts collection, I think, number 5, explore content, formats. So I have this it's probably not relevant for you, but I have an AutoCAD file here. I don't have AutoCAD, but I can open my file thanks to the format preview that we have in the platform. And what happens if I would like to create a PDF file? I can click here, and the system immediately creates a PDF file for this format. This, as I told you at the beginning, this works for more than 300 formats, the same. So with any file, you can do exactly the same. It's really convenient when searching to look at the content, quickly be able to open it even without downloading, even if you don't have the software to open it, and so on. When you are searching, you can start increasing the level of the complexity of your query. So the one we have been looking at is search, simple search by a word, and so on. But what if we are searching for a particular metadata? So I don't know, dates. I'm interested in or contributor. I'm interested only in searching in the contributor field. I just need to start writing contributor, and I have my field, and then I can write some value, and I will create a query in which I will get the objects that for the DC contributor have or include this value. But this can even be done in a more complex way. You remember that I told you at the beginning that we have Elasticsearch under the hood. So everything that gets ingested into the platform is also indexed in an Elasticsearch index. While we are not offering direct access to the Elasticsearch index, because this could create a permissions problem, so users could see things from other users and so on, we are allowing you to have a broad access to the search API by adding those permissions and so on. So this means that you can launch queries to the system in the, I would say, most common and the most industry used domain-specific language, Elasticsearch. So if you know how to build queries in Elasticsearch, you can immediately start using them in LabDrive. If you don't, like for instance, I don't know how to create them, I can see the fields that I can use that I have available in the platform. I can see them, and I have many examples on how to perform those queries. So for instance, I'm searching only for objects that are files, or I would like to search for ranges on metadata. So I would like to get all the elements that are inside one container that is a child of the archival structure 1, 2, or 3, or one element that in the field, whatever, contain this text or this text or this text. You can also query for ranges of dates. So give me every object that has been updated from this date to this date, right? So you can use those operators and so on. And you have examples on how to use it with your own metadata and so on, right? So many examples on how this can be used. You would need to just copy the query, edit it in the new query interface, and you would be getting your results. So this is searching through the API. But what if we want to search using the interface? But what if we need to use using the API? So you can go to the API. Well, first go to the documentation, so I show it to you how it works. You have in the getting started, you have searching, right? And then everything that I explained to you on how to search is explained here. And in addition, you have the searching using the API. So let's say I would like to search for everything that is inside the container number 5, the one we have been looking at. I have this method. I will update the container number to 5. And I don't exactly remember, maybe this one. Yes. So now the system is telling me that I have 630 elements that are matching my criteria, which my criteria is for them to be in one container. And then it is giving me the results for all of them. So it is telling me that this file with this metadata is there, and so on. So this file is this one. So if you can see, DC date submitted, this is my metadata, DC title alternative, I can edit it from the interface. So this is the metadata for this object. If I go to the interface, to the container we were in, manuscripts collection, I search for this item. The item is here, so I open it. I have this one, and if I click to see the metadata, you can see that this field, I have my metadata here in the same way, in a consistent way to how the API is showing it to me. You have many other things here. So you have the hashes for the file. Well, you have a full view of everything that the system knows about your file, can be retrieved using this, this API call for your files and so on. So you can also do that in a more specific way. So what happens if you are looking for a specific element of your content? So, for instance, I think I have probably container. Yes, this will work, for instance. So we are searching here for anything in any container in the platform that in the metadata DC description abstract. So in this DC description abstract, it contains the word API. It could be the word, or it could be a value, or yeah. So if you have, so for instance, this has been extensively used in one of the use cases in the PIC one. So they are getting data from telescopes, and each data package is coming with 13 fields that are assigned by the platform, reading from a JSON file that is coming with them. So you could easily give me all the data sets that I have from this telescope, from this date to this date, or from these coordinates, or whatever, right? So you can create those queries, and those queries are going to can be used for searching. So in this case, I'm using this, and the system is telling me that I have one hit, so one result. The object is this one with the metadata. Let me colorize it for you. Yeah, my metadata, my hashes files, and so on. So the full path, in case you would like to download it, and so on. So this could allow, we have many examples in the documentation on how this can be used. So for instance, searching by container, you can include searching on multiple containers. You can search by file names. You can include operators and or not file formats, and so on. You can search by your own metadata, the metadata you are providing. But there are, this is the basic way of searching. You have also an extended way of searching that we have documented also, advanced API file search, that includes many other things you can use for searching. So the structure, the type, the MIME type, the date created, the storage, if it starts, includes, it's equal, not, is greater than, and so on. So you can see that, give me all the files that are stored in a cold storage that contain this word and were created 1 year ago. This could be, it could take a few minutes to build this query, and you can immediately get those results. In addition to be able to use the API for searching, we are also, as part of the ARCHIVER project, we have started to build a CLI tool. The CLI tool is under the hood using Python, using the library that is also available for you. So you can build your own CLI tools, and the source code for this CLI tool is open source. So you can get it, and you can modify this tool in the way you want, is this tool has been created to basically demonstrate one of the use cases to download every file that is matching certain criteria. So you have a CLI tool that you can launch with one of those search queries, right? So this search query, these conditions. So then you can, if someone is asking you for all the files from this telescope or whatever, you can get this query, send them to the user send it to the user that is going to need to download those files, and they can download this CLI tool, run it with this search query, and the search tool will verify that the user has access to those files, of course, then will download your files. If your files are already there, the system will hash them and verify that the hashes are the same, and if not, will re-download them. So this works even if you interrupt it and relaunch it, it is able to get it synchronized, and so on, right? So it's a very quick way of doing it. I don't know if I have the CLI installed, but if not, in the next, as we're going to see it in the next blog, I will be showing it to you how it works. So basically, to summarize in this section, you have been able to see. Let me open this again. You have been able to see how to create a container using the graphical interface, using the API, how you can upload a content using the browser, using S3, or downloading it using the same two methods, and searching using the graphical user interface and the API. So I think we have some questions. Let's address them. So I have the first one that I see is from Alfred. Alfred is asking us, can programs for automated submission jobs, preservation planning, file migration in LabDrive be written in Java too? We have, so you can of course use Java to write code for the platform. But if you want for this code to be executed in the platform, you can execute on your own environment and use the API to interact with the platform. And this would allow you to execute any language. We have some Java examples here and there in the documentation. But if you want to write them in Java and execute, you can. The platform allows you, but you are going to be alone, because all examples that we're writing, all documentation we're writing, and so on, the libraries we're writing are in Python. So we have adopted Python as the main language for users to create their own components and so on. So you can run Java code, but you will have no documentation and no libraries on how to interact with the platform for now. So this is, as always, changing based on demand. So the strong demand is Python for now. So I would say now a 9 out of 10 would ask us in this environment to run a Python code, but we have support for other languages. Okay, Anonymous is asking, do we have a roadmap to support other public clouds, such as Google Cloud? Not at this point. So we have been working a lot with the Amazon team to optimize the platform for running in the Amazon environment. So as a service, our plans include offering only for Amazon for now, but you can always get the on-prem version and run it in the cloud you wish. So when getting LabDrive, you have two options. You have the option of getting it as a service. We are offering it in 15 regions worldwide now. So you can choose in many areas in the States, Europe, Singapore, and other places in Canada, and so on. So 15 in total. So and you can get it as a service. And the service is going to be based on Amazon. This has been done this way for two main reasons. The first one is that the performance level we are getting with Amazon and using their services and so on, we have been working hours, months to optimize it. And now it is extremely good, extremely fast, and extremely stable. And we don't want to change that for the service offer, right? So Amazon is one of the most recognized offers there, and we're going to stick with that for the public cloud. And the second option is you running it on-prem. On-prem means by your own means. So we will help you to deploy the platform. We will provide a software license, and you can deploy it on your own premises. So if you have an OpenStack platform, you have a Kubernetes cluster, you can deploy it on-prem, and of course, you can deploy it in the cloud. Google Cloud meets basic criteria for this to work, right? So you can deploy it in one of their Kubernetes cluster and so on. Of course, we are recommending for you to go, unless you have a strict requirement, we will always recommend for you to run it in the Amazon and getting it as a service. There is one advantage for you, is that when you are getting service from the platform, we are creating those the service clusters on those countries and geographical zones, and those clusters are not just serving you, not just serving your user, your tenant. They can be using the computing power, the total computing power that we assign them in the region. So this means that for certain components, your capacity is going to be reserved. So you will have always a capacity to execute processes in the platform, but you can always consume everything that is available to you. And this is a massive benefit, right? So this allows you to run 10, 20 times faster than the rates we commit for you to execute, which are extremely, extremely large. But you can, will be all usually going faster. So yeah. So regarding to the cloud, Jasper is asking us, once the data is there in LabDrive, how the data analytics and artificial intelligence tools are going to get access to this data using S3 APIs. You are right. The default tools that are able to work with S3 compliant endpoints will immediately work using the S3 protocol. Nothing prevents you to run your own, to create your own scripts, to interact with the API and so on. So we have an example in which someone was running a Jupyter notebook outside of the platform because they needed a specific computing environment, and they needed for their notebook to run a search process, and over those results perform some analytics over the data. So this, as you can see, combines both things. They use the Python library to create the query, and with the results, with each of them, you have the S3 endpoint. And with the S3 endpoint, you can get your file using S3, and you can process it. So you can only use S3 or combine API plus S3. Alfred is asking, can you manage two types of metadata, one with indexing for self-map metadata and one without indexing for source MD? In principle, everything is indexed in the platform. So you can have two types of metadata. You can have whatever the types you want. So it's not limited to 2 or to 1. So you can have 100 types of metadata, but everything is indexed by default. But of course, you can exclude those fields to be searched, right? So this is highly related to the approach that I told you at the beginning. The approach in the platform is trying to provide a standard, a baseline for everything, and then you can restrict those search results to remove the fields you don't want to search. How far does LabDrive support creating, tracking, updating, and visualizing web archive files? LabDrive is not the component that is usually used for visualizing work files and Web Archive files, but LabDrive is using the same component that other products in the company are using. The Web Archive is more related usually to the academic, cultural heritage kind of things, and we have another product line that is really close to LabDrive, which is called LibSafe Go, that includes the capability of creating work files, indexing and managing them, and displaying them. You can contact us by mail, and we can organize a demonstration on how this works. So the final answer is, while technically possible, we are not including this feature in the default LabDrive offer as a kind of differentiation between both products. But the architecture is the same. So if you have a specific need that is related to LabDrive and involves Web Archives, we should discuss it. And the last question is, how are the intellectual entity representation implemented in LabDrive? We don't have time today to cover this, but the good news is that you have a whole section of the documentation that is going to be telling you, in this case, how to deal with additional representation information, how to organize, how to create those structures with examples on how you can use them, the packaging information and so on, pointing to other sections on how everything is structured and so on. So my recommendation would be for you to look at the data curation and preservation section on the documentation, because this question is answered there, and you have also examples on how everything is mapped to LabDrive. So I think it's time for a break. That's correct. We have 30 minutes for lunch planned for now. So let's reconvene in 30 minutes, 1:30. Thank you, everyone.
One minute, Antonio.
Very good.
Okay. Yep. Let's get started.
Very good. So I have been asking to my colleagues, in order to properly answer the previous question about the languages and the Java code and so on. So you can run .NET, Go, Java, Node, Python, Shell, or precompile images in the environment, right? So as part of a function. So I told you documentation is going to be for Python, but you can run all those code there, and you can do really advanced things, right? So we're going to see a basic introduction today to the functions, but you can let the platform process really large quantities of data in multiple ways and so on. So there are many options on things that can be done there. Okay, so functions. I told you that at the beginning, so that those functions, you can understand them as macros that are running as part of the platform. So you can use them for many things. You can use them to create a report, to rename files, to do a format conversion for preservation planning. So for instance, we have functions already in the platform that are capable of performing close to 80,000 file format crosswalks. We have I would say one of the, if not the largest in the industry, set of conversion rules. So almost one for any format can be converted to other. We're extending this to the research data field. But yeah, we have functions that are able to perform this. How are how you can run code in when working with LabDrive. So you have two large ways, and the one is in the platform, and the other group if it's outside of the platform. So outside of the platform would mean that you could be running your own scripts on your own computing platform that are going to be interacting with the platform. So you are going to be in charge of managing this workload, this code, and so on. It works in exactly the same way for everything that that we're going to be looking at now. But the second group is that running things inside the platform. Inside the platform, you can run it in three main ways. The first one is a non-interactive way. So the platform is running the process in the background. Those are functions. The second is in an interactive way. So for instance, you can run Jupyter notebooks to execute something step by step and to see what happens. It may be a traditional analytics Jupyter notebook, or it could be a Jupyter notebook that is renaming your files or grouping them based on the content or whatever, right? So you can anything that you can run inside a Jupyter notebook, you can run it there. We will see some examples. And of course, you can run it on your own environment. In the platform, we have a functionality that is the custom Docker containers. So now, for instance, for the instances I'm going to show today, we have a custom Docker container running, which is the Rihanna environment. So by using this functionality, we're making Rihanna to connect and to be able to run in the LabDrive environment, inheriting permissions, monitoring, logging, and so on, right? So as part of the platform, you can also run your custom Docker containers as part of the platform. So let's say you have a particular analytics software that you have containerized as one or many Docker containers. You can also make them part of the platform and to be integrated in the platform. So the ones we're going to be focusing today are those two here, the non-interactive way and the interactive way. For the non-interactive way, you have the concept of functions. Those are documented in the developer's guide functions. Here you can see how they work. As I told you, they can be executed as a response of certain operations on the files or metadata in the platform. The system will execute them when you change the metadata for an object without you to need to do nothing. They can be also scheduled to be executed periodically, every second, every minute, every month, or they can also be executed by demand by the users, right? So, which is also pretty convenient. So, how to build a function? So first of all, you need to declare it in the interface. To do so, you need to go to the functions menu, to add a new function, and then you will need to start configuring it. I have a function, let me see, yes. So you go to configuration, you go to functions, and then you have all the functions that you have installed or declare in your environment. I have a function here that expands PST files, another one that renames things, another one that applies format conversion for my files, and so on. I have several functions declared in the platform. There is one, this one, which is the demo function. If we edit this function, if you would like to create one, you click in add, and you are going to get exactly the same interface. And there are four things that are relevant to the function. The first one is, of course, the code that the function is going to be executing. In this case, how to create this code and some examples is also documented here. You have a pretty good example of a skeleton of the function. Here you could be adding your code, right? So your code could be here, and everything else is the helper, login, and so on, everything that is initialized for the platform. And as part of the documentation, we're explaining you what is done in each block, how you can create your own functions, how can be, everything can be done, and so on. So you have a pretty good documentation on how this works. But basically, we have our code here, and our code, as you can see, is going to initialize the environment. It's going to log a hello world output. This is going to also log an error message. It's going to log 13 parameters there. It's going to inform us about more information, parameters selected by the user or whatever. And then it is going to create a file. As you can see, it is creating a temporary file that then is uploading to the container. So this line here is uploading the temporary file we created with some text. It's uploading it to the container, and then it's going to finish, report back, log the output, and that's it. So you have your code. The next step is compiling this code. To compile it, this is already compiled, but I'm going to recompile it again. You just need to click save. When you click save, the platform is going to, this function is going to start compiling it, building it. So as you can see, under the hood, this is creating a Docker image with the code of the function running inside. And this may not be relevant for you, but it's incredibly interesting because those functions are running in memory. So this code is running in the number of replicas you define. So the minimum is 0, which is not running. So you can also set that. But if you have it running in memory, this is extremely fast. So it is able to process millions of files in minutes. So because the function is pre-compiled, so even if it's Python, we're compiling it under the hood and deploying it to a Docker image that then is looking to the event queue to execute those actions. This function has been deployed, if not, has been built and deployed to the platform. So you need to do nothing else. As you can see, you have the source code and that's it. You click save and the complexity, all the complexity is happening under the hood. Another thing you can configure is basically the configuration. The only interesting things here are the replicas. You may request the platform to run 100 parallel functions. So this will be able to handle 100 processes in parallel, right? So the replicas are managed here, or you can leave it to 1 or to 0 if you would like for the system to auto-scale them as needed. And then the build commands. If you would like to install something on the Docker image, you can include it in the build commands, and we will take into consideration when building it. The next section is the triggers. What is going to trigger this function? In this case, I have only one trigger, which is the on-demand. On-demand is someone is going to be telling me to execute, but you can add other types of triggers. So you can tell when a file is created, when a file is deleted, when the storage is changed, when the metadata is changed, and so on, right? So you have several parameters and options. You can tell the system to auto-execute those functions. And one of those types is on workflow change, right? So which is linking functions to workflows. The one that I have is the on-demand, and you can see that it's called some sample function. And the fourth element is the one that includes the parameters. You can tell the platform when someone is launching this function, ask them for something. So let's say you are doing something pretty basic, a rename function, renaming all files you have in a folder with a prefix. The prefix is something you would like to let the user decide on and input it to the platform. Then you could be creating a new field. Let's call it prefix. The label would be include here, the prefix for your whatever. The type would be a string, and the default value would be my prefix. And you can set it to require or not. If I save it, I'm not going to be saving it, but if I save it, I have declared a new parameter. So as my trigger is on demand and I'm telling the platform to show these on every node in the archival in the platform. You can also restrict when this function is available and for whom and so on. But I'm telling the platform to show it to everyone. If I go to a given container, this one, I have my sample function here. So this text, as you can see, is the one I am declaring as part of my trigger here. Sample function. So you have it here. If I click run it, the platform is going to ask me the parameters that I have in the configuration that should be requested. These 3 parameters: sample parameter 1, select a file, select one option. Sample parameter 1, archival structure, select a file, archival structure, and select one option. Depending on the type you are setting, string, file, enum, whatever, you have different types of folders, a type of things. So in this one, I'm asking the platform to show a container selector and a file selector for any file that I have in my container, right? So an option and a label or whatever. If I click OK, this function will be executed. The function is running under the hood, but you can follow its execution clicking here. If I click here, I'm going to open the execution details. As this is fairly simple, this function has already completed. It is giving me the summary of execution, right? So it is telling me the process 1 has finished fine, the second one and the third process failed. This is all fake, right? It's low for demonstration purposes. Functions are able also to create files. You remember it from the source code. So we told these functions to create an asset that is added to your container and accessible here. And then we have the code executing. You remember in my code, the hello world here. Hello world, this is an error message, and I have my error message here with the error. You can filter them, you can report. We have the logs of everything that has been executed. The options that I have selected are passed to the function, and so on and so on, right? So you can see that this is the basic way in which you can be running any kind of code in response to user requests, to platform events, and so on. We have a fairly large collection of functions already created, and we are starting to build the documentation to make them public. We have published like 4 or 5 already, but we will continue publishing all of them. And the plans are for the users to be able to create them and mark them, identify them as public functions. And if they do so, other LabDrive organizations would be able to use other customer functions and so on. So we are trying to make easy for you to work together with other organizations, sharing those functions, pieces of code, and so on. In the same way, you can execute the function using the interface. As always, you can execute it using the API. So you just need to make a request for the function to be executed. In this case, we are executing a function using an API call, right? So you can also send its parameters. So I would like to execute the function number 3 in the container number 7, using the input of the files with the parameters, whatever. So parameters can also be sent using the API. And this is going to trigger this workload into the platform. You can also see when those functions have been completed. You can request the job, whatever, for the function, and the system is going to tell you if the function is still running, if it has been completed, if it failed. And you can access the logs for the functions using also an API call. So this way, you can see that you can create fairly complex workflows by your own. Of course, we would be here to help you on building them, but if not, you can build them on your own. So you can build a process that is going to upload a tar file and then trigger the function for the tar to be uncompressed, validation is validated, the metadata is imported, and so on, all managed on your side or in the platform side. You decide on how this is implemented. You can also access assets and so on for those functions. So in the middle way of these functions is the scripting. So as you have those curl commands and so on, you have several use cases that may come handy, and that with a very little scripting, you can do really complex or really powerful processes. So let's say that you have a function that is going to convert a file format to another, but you would like to run it over every item in your container. You can easily create, obtain the details for a file, create a search. So give me all the files in this container, process using this Linux utility. You can create a list of the identifiers that are matching your query. And based on those identifiers, you can process it and launch a function, right? So with a few lines of code and a few minutes, you can perform operations in batch for all the content you have in any way you can imagine. So in this way, we're doing copy content from one container to another one. Of course, this is not a standard copy, because we could be copying it with the S3 copy from container A to container B. This is way more advanced. So we are listing the files that we would like to get included, and then we are launching a parallel copy from it. So this means, in this case, we move, in this example that we have here, we move 40 terabytes of content in less than 6 minutes, right? So it is parallelizing, as S3 parallelize a lot. It's able to parallelize a lot those workloads. It moves incredible large workloads in a matter of a few seconds or minutes. So this is very good for large amounts of content and so on. So this is the first way of running it, the functions running code, the functions way. The second way is the interactive way, which is the Jupyter notebooks. Jupyter notebooks, how we use Jupyter notebooks may be confusing, because we use Jupyter notebooks in the platform for two different things. The first one is running your code that is going to interact with your data and probably transform or convert it, but in an interactive way. Or we can run analysis and reproducibility examples in the platform. In this case, this is the third platform. They have one Jupyter notebook that is one of their experiments that is analyzing some data that is in some root files and so on. So this is an experiment that is available as a Jupyter notebook in the public CERN website. We downloaded it. We save it in LabDrive. The code is exactly the same they have, and you can immediately click here and execute the code. This is a fairly complex workload, so it will take a few seconds to execute, but you can see how the platform is executing it. All this workload, this Jupyter notebook, is part of LabDrive. You have it when you get LabDrive. The capability of having your Jupyter alongside with your data, the data for this Jupyter is here, it's in this root file, is one of the, I would say, benefits that I would highlight more about LabDrive. Now your data and your code can live together, and you can, at any point in time, open your Jupyter notebooks and execute them in the platform, right? So this is very convenient. It will need probably a few seconds more to complete. Yes, we have it. So as you can see, the result of this is this diagram, this that we have here, that the platform has executed and so on. So we are basically executing reproducibility load within LabDrive without using any external tool. So the data and the code is here. This is fine this is really good and an excellent approach for Jupyter Notebooks. But what if you have a more complex workload? So let's say you have a Rihanna experiment here, a Rihanna workflow. This Rihanna file is a YAML file. Sorry, it's a YAML file. So I'm going to show it to you. This YAML, well, Rihanna, for the ones that are not that don't know it, Rihanna is a Thurn, it's a reproducibility and workflow execution environment that was created by the Thurn, and we included it, embedded it in LabDrive. This basically allows you to define a workflow on how certain data should be processed in order to keep everything that is needed to reproduce a certain experiment. In this case, what we have here is a workflow that is telling us execute it in a serial way. So we can also execute it in a parallel way. We demonstrated it in the ARCHIVER project. And then the steps are, first, you need to compile using this environment. You need to compile this file here, which is C code here, which is part of the things we have in the platform. We have C code here in the platform. So the next step, the next step is to run the thing we have compiled using the same environment. And the output of the process is going to be a demo report.pdf. So the output of this workflow will be this PDF file. It could be anything. In this case, it's just a PDF file. So what I can do is that I can just select my Rihanna YAML file and I can run my workflow here. I click run. The system will create will call a function that will executing this Rihanna code that is running. And you can see this is cute. This takes a few minutes to complete it. It's a fairly large process, but it is going to complete it, and eventually, so it's cute. Now it's pending. Now it's running, and in a few minutes we will have it completed. It is still running. We made it to report every 10 seconds. So this can be changed. This is a function, so you can change it by your own if you wish. It's still running. Well, I don't want to waste your time, so we will come back to this. It may take another 2 or 3 minutes to complete, right? So we will come back here. In the meanwhile, I would like to explain you about reports and data analytics. We have several reports already built in, global reports for many things like understanding, preservation related, data related, and so on. It is possible for you to add your own. We have the performance and analytics one, which is showing you the status of the platform, all the functions that are running. You can see this is the function that I'm running. It is running one in parallel and it is working, right? So the platform is telling me that this is executing. And then you have the carbon footprint report. I briefly told you at the beginning. So this is getting real-time emissions, and it is getting everything that the platform is doing, and it is basically mapping it on how emissions are produced by the platform. So you have an evolution over over time. You have different processes that are using it, so how they are evolving over time. You have them also by source, and you can of course filter by month, year, and so on. You have also the distribution of the emissions depending on the type and subtype of storage you are using in the platform. The S3, hot S3, it is creating way more emissions than Deep Archive, right? So if you would also to reduce the emissions in the platform, Deep Archive is a good way to do so. So here you have the outcome of this, as we are only using hot archive, hot storage. This is the main source of CO emissions by sources. So you can see that the main two sources are the functions that I'm executing and the platform. And you can see, depending on if those other sources, from where those other sources are coming. So cooling, power, lighting, and fire suppression systems are also taken into consideration when making this information. You can also see the emissions you are creating by region. Depending on where the platform is executing things, you will create emissions in one area or another, and the system is also tracking this. So you can see that we're creating emissions in this instance in the States, in UK, and in Germany. And most of them are created in Germany, but are so low that you can barely see the difference in the green, right? So because it's a very low emission. And you can get the numbers. So if you would like to process them by your own or do your own calculations or create your own reports, you have them, you can filter, and you can also export them as a CSV. So you can see what is the impact the platform is making in the environment. Let's see if this has finished. Yes, the function has been completed, the Rihanna workflows. You can see it all was finished almost when I switched to the report. The workflow was finished, and here it is giving you the output of the Rihanna process in case you would like to see it. So now in your container, you had those two files, but now you have a folder called results that the system is creating with the report, with everything that Rihanna produced, including the PDF with the report, right? So any workload in this way can be executed. We are supporting SnakeMake on other frameworks, and we will include more in the close feature. You can see that how both things could be combined, right? So data reproducibility together in the same platform. Okay, we have been able to see Jupyter. We have been able to see Rihanna. We are in the reports. Sorry for switching back and forth. We were in the carbon footprint. Yeah, I was about to say that we are working, we have been unable to have it ready by the end of the ARCHIVER project. This has been extremely stressful because the demand of adding new functionalities has been really high during the project. So we have been unable to complete it, but we have on roadmap to be delivered after the summer, the integration with Metabase. Metabase is, you may be perhaps familiar with Tableau, for instance, or Power BI. Metabase is another alternative. So we are integrating it with LabDrive. So the ones that would like to use it, they can use their Metabase instance to connect to the LabDrive instance and create their own reports and data analytics over the content that is in the platform. So yeah, basically custom reports. I briefly told you for the reports for the containers, but The same goes for the global reports. So you can export them as CSV files, and you can also schedule them. So you can tell, I would like to have this report every 15th of the month, and the system will send it to you. So you can, here you have notifications. Here you can add who should be able to get it. I have no accounts here, but if you do, you could see them here. You can select the ones that should be able to receive them, and the platform will create those reports and send them by mail. Okay, so then let's do a quick, let's review that we are missing nothing. Okay, very good. So then let's do a recap, a quick recap for the platform. Many of the things that I told you at the beginning will have, will be more easy to understand now after the training, and we will address the questions we have. So remember that this is a research data management and preservation platform. It's not only an archiving and preservation platform. You can keep your data live, and the design principles we are using is for it to be unified, allow you to all these things that are here and there, combine all of them in a single platform. It is comprehensive in the way that, as I said, it's not only allowing you to preserve and archive, it is also allowing you to handle the whole life cycle of the data, of the research data, capturing it with the capability of capturing it as soon as it is generated, of course, also at the end, but capturing it as soon as it is created has many benefits. It's also a platform that allows your teams to work together over a shared platform, sharing permissions, policies, metadata, search, everything you have been able to see. And we are really open on the approach we have designed it. So the platform is going to be ISO 16363 As I told you, this is the gold standard in the industry for preservation. It's fully aligned to OIs, and we are certified in the platform. The scope of the certification includes the platform, the ISO 27001, 17, and 18. So PII, GDPR, personal identifiable information managing, and enhanced security controls for the cloud. One relevant, really important point is that 100% of the information that we have in the platform can be easily exported the day you decide that you would like to export the platform. And you have been able to see it at the end. You can basically extend it to do whatever you want by using those macros and functions. So we have been able to see we have the lab drive working in several organizations, and we are able to see that they are making it theirs. They are extending the platform in several ways to connect it to their workflows, the way they work, and so on. And we needed to do no changes to the architecture, right? Which is, in my opinion, a really good sign that the architecture is extensible enough to handle today's needs. Okay, questions. Alfred is asking, is there always the possibility to undo a step you did, versioning of files, metadata, function scripts, and configurations? This depends. If you want for the steps, so everything you are doing with the API and the interface, you can revert it back. So if you delete a file, you can recover it. But what happens if you empty the recycle bin, right? Then this can't be undone. The system is going to inform you, and we're keeping a backup of everything. But under normal circumstances, there are things that you can undo, and things that you can because of the nature of them. The most usual things: adding metadata, deleting fields, deleting files, overwriting them is there. So you can revert it back. Regarding the two functions, depends. If your function, if the code of your function considers the option of running the step back, then you will have it. So it depends on how you create them, scripts and so on. And configuration is exactly the same. So as you have the log you saw, if you change something in the log, the platform is retaining whatever you are changing, but also the values that those fields had previously to the change. So you can always revert it back. And this would be the things you can do on your own. But let's say you delete all your users, right? You can always ask us. There's a very strong backup policy behind the scenes. So this will be in one of those latest backups, and using a support request. If you are using the service option, the cloud option, we can handle it and correct it. Alfred is telling us also and comprehend that what have been done earlier, automatic documentation of execute code, done steps and so on. Again, this depends on your workload. If your workload is leaving trace of what has been executed, yes, you have it, which is the default way of those functions to work, right? So as you have been able to see in the function I execute for the Rihanna code, in the log, the platform captured the output on what was executed, and in the results folder, it created the YAML file and the C code and the C++ code. I don't remember if it was C or C++, the C code that was executed, right? So if you retain this folder, you are retaining the execution snapshot, right? If you delete it, then of course you are going to be deleted. Someone is asking, just curious, is the function underpinned by Lambda behind the thing? It's a pod running in Kubernetes. It's a whole set of pods. We have a Nucleo engine running under the hood. So it's a whole framework and engine for running this kind of parallelized workloads. At the end, when you compile a function, this will create a Docker image that will have your code running there, waiting. So the code is embedded in a framework that is looking for an event to happen or to be received, and then it is sending it through a pipe, execute, and the output is sent back to the platform. So this is really fast because it's using on memory mapped area, so everything has been optimized for performance. So ultimately, it is running in the Kubernetes engine as a pod. You are right. So, but there are many steps and things there. Can every code inside LabDrive do email messages? I'm not sure what you refer by code. If what you are thinking is that can reports or can you get notifications on certain events on the platform? Yes, you can. So you have, not absolutely sure where this is here. So for instance, the notifications, you have several notifications that I have enabled here to notify me with when a new container is created, with a container action is finished, and so on. So you can have notifications. For the reports, you can get also notifications, and of course, functions can send you notifications. So email messages, and I think it's part of the, so you have an abstraction method in the library to be sending email messages. So I would say that with functions, you can do notifications on everything if needed. Okay. More questions, things you would like for us to demonstrate, to see, to go deeper. Archiver team that is with us. Do we have any question?
They know everything about LabDrive.
I know. We will be 1 minute for extra questions. You have the form that we have provided. Please give us some feedback on this training. You have my email message, and there you can also use the contact@libnova.com if you'd like to get in contact with my colleagues. We would be happy to do any presentation you need to showcase any functionality on the product. So we're happy to help you in any possible way. So you just need to contact us.
Yes, if there's no further questions, you have in the chat again, my colleague has included the assessment link. So thank you all for your participation. And as Antonio has just said, this is just the beginning of the journey. Please ask us anything, request, whatever you need. We can organize face-to-face meetings if you have some specific, precise needs that in this overall training, this lengthy overview, but maybe there's some things that we have skipped just in the interest of time. There are many things, as Antonio mentioned at the beginning, lots of documentation, and we can provide more things for you. So thank you very much. And I don't know if either Sarah or Sonia, on behalf of the organizers, want to say something. If not, we are ahead of the plan, but I think we cover everything and also answer all the questions. So Sonia, Sarah, if you have something else.
So this is Leticia from Trust IT from ARCHIVER. Thank you very much for your webinar today, very interesting. And just to highlight the comment in the chat from Maria of Libnova. So it's important that you, have the link for the registration, the assessment, if you can complete your attendance registration and your submit the assessment. Thanks all. We are available also here in ARCHIVER, obviously, for any information, any additional details that you need. That's all. I'd say there is an email from Libnova also for contacting them. So contact@libnova.com in the chat. Thank you to the speaker also, obviously. Thank you very much.
Thank you for organizing everything. And thank you everyone for your time. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye. Have a good day all. Bye.